and implementations of networks. That's sort of a broad term, but it just kind of means what sort of network technologies do we have to see and interact with on a daily basis. So we'll start with a couple of network services that are going to be present in every network that you work on or work in. DHCP to assign IP addresses and DNS to resolve names to IP addresses. Again, you'll find those in every single implementation of a network that you are, even in home networks, just because they are required. Another thing you'll frequently find is going to be wireless implementations. And we've briefly talked about it in a couple of cases, but we're going to look at the different wireless standards, wireless security, and the setup that's involved in allowing users to communicate over the network using radio frequencies. Remote access is another very common thing to experience, especially in today's world in 2022. In light of where we're at, we have lots of teleworkers. We have lots of people not coming into the office every day and instead utilizing remote access technologies to be able to remotely connect to their business from their home. Or from anywhere else for that matter. Kind of along with that is the cloud. Okay, now just because you have remote access doesn't mean you're remote accessing into the cloud, but the cloud and virtualization has grown as well as of late, and so we're going to look at the different concepts and technologies that are behind that. In this first topic, we're going to talk about network services. The network services that we're dealing with, again, are DNS and DHCP. These are services that are required on every network, whether you set them up or just deal with the kind of the client connectivity end of it. It doesn't really matter. This is very important information to know. So let's start with DHCP. DHCP is Dynamic Host Configuration Protocol. This is an application layer protocol and service, and it's responsible for dynamically assigning IP addresses, subnet mask, and potentially other configuration options to network computers. And there's a lot of advantages to using DHCP, which is why it is used predominantly for client computers. Servers and printers and switches and routers, those probably have what we would call a static IP address. It doesn't change, but clients will typically get automatically assigned an IP address when they boot up, and we'll go through that process. Why is this beneficial? Well, because it avoids manual client configuration. Just miskeying one number, specifically in the network portion of an IP address or in the subnet mask, will prevent network communication. Okay, so just individual user errors when configuring it would cause problems. Not to mention the fact that we're talking about end users configuring their own IP addresses. End users are typically not even going to know what an IP address is, right? So we don't want to have to manually configure things. Additionally, it provides a mechanism for moving client computers because your IP address is very dependent on the network that you are currently connected to, yes? So if you're on network 1, then you're going to get one IP address. If you're on network 2, you're going to get a different IP address. Think about if I had to change, every time I changed networks, I had to change my IP address. Well, that's what would happen with the manual configuration. And especially today, I mean, we're talking Ethernet and wireless. We're talking any type of network change. It also avoids recording IP address configuration because it's going to be housed in a DHCP database. This reduces, not eliminates, but greatly reduces the duplicate IP addresses. If you've only got one DHCP server, then you virtually will eliminate duplicate IP addresses. Okay. If you have multiple DHCP servers, they have to be configured to talk to one another, to work together, so as not to duplicate IP addresses. And in any instance, somebody can go and try to assign a static address to their machine that could cause a duplicate. And just ultimately, it eliminates common cause for network communication issues. One of the very first things we look at if we're having trouble communicating over the network is your IP address configuration. Is it correct in the particular network that you find yourself? And so, usually that doesn't mean with DHCP we don't ever need to check, but it does typically eliminate that. So DHCP servers sit and maintain a database. That database contains scopes of IP addresses, or a range is another word for it, that are leased out to clients, and the clients will request those when they boot up. Now, the IP addresses are assigned by DHCP and they're given out for a finite period of time. It's known as a lease. So I'm not getting an IP address permanently. I'm going through what's called the lease generation process. Every time the computer boots up and is connected to a different network, this lease generation process will occur. The very first packet, it's a 4-step process. Very first packet is the DHCP Discover packet. Okay, this is a broadcast packet from the client that the server receives. We shouldn't say really to the server. It's a broadcast. Everybody gets it, but only the server that's running DHCP service listening on TCP UDP port 67 is going to respond, right? So I'm sending out a broadcast basically yelling out, hey, I need an IP address. Any DHCP server that hears that broadcast is going to broadcast back a DHCP offer packet. Okay, now that it's a network broadcast, but it does contain an IP address that's being offered, which would be the first available one from the range on the server, the IP address that's being offered, the server's IP address to identify itself, and then the client's MAC address, which would have been in the original broadcast frame. Everybody's going to get that packet, but only the machine whose MAC address is identified in there is actually going to process it. And so that machine will process, it'll send a DHCP request where it's basically just requesting that IP. Again, I still can't do unicast traffic as a client. I'm still having to broadcast, but in the broadcast, I'm going to put the server IP and the offered MAC address. And then the DHCP server will send an acknowledgement. At that point, the IP is assigned to the client, and the client is up and running. Now, you will always get an IP and a subnet mask. You generally will always get a default gateway. There are additional configuration options that we could give you, such as DNS servers, DNS domain names, boot file servers for like remote installations, Windows deployment services. It used to, back in the day, it was Win servers, NetBIOS. There are all kinds of options. Typically, we just use the router option for the gateway and the DNS server option. Those are going to be the most common additional configurations. It's a good idea to know this 4-step process: discover, offer, request, acknowledge. Now, we said you get the lease for a finite period of time. You don't have it for good. That period of time is dependent on the lease duration setting, which is just a setting on the DHCP server itself. And to be clear, DHCP servers could be Windows servers. They are in a lot of environments. They could also be routers, firewalls, a lot of network devices, layer 3 network devices and up are going to have the ability to function as a DHCP server. So in any case, though, there's a lease duration, and that's the length of time that the lease is valid. And so if a lease runs out without a client communicating with DHCP, then they're not going to be able to communicate over the network. Okay, so they'll go through this lease renewal process. At 50% of the lease, they'll send a DHCP renewal request, only this time they know who their DHCP server is, so I send it directly to that server. If the server's available, then the client's immediately assigned a new lease. Basically, just IP address is not going to change. It's just given a new, end time. At 87.5% of the lease duration, the client sends out a DHCP Discover packet again, because now I've already tried to communicate with DHCP for whatever reason. If it wasn't running, then I'm going to wait, till just before it's going to expire, and now I'll send out a broadcast and I'll accept one from anybody. Okay, at 100% of the lease duration, it'll try to get an address again, and only if it's successful will it still be connected to the network. So when the lease runs out, if you cannot communicate with DHCP, then you would get an automatic private IP address, a 169.254, which is always a good indicator that there's a problem. Okay, default lease duration on Windows servers is 8 days. I don't think that matters that you remember that. It's just whatever the lease duration is, at half that duration, that's when the client's going to start trying to renew its lease. Okay, renewing a lease and generating the lease, this is all network traffic. Now, it's minimal network traffic in most environments, but it's network traffic nonetheless. So the length of the lease duration is going to have a direct effect on the amount of DHCP traffic. The longer the leases, the less traffic. Okay, but the longer the leases, the longer an IP address stays assigned to a particular computer. And then sometimes in wireless scenarios, this is important. In a wireless scenario, you would have computers that are joining the network and then leaving the network. The deal is, when you leave the network, the client doesn't actually say to the server, hey, by the way, you can make that IP address available for somebody else. That doesn't happen. And therein lies the problem. Ethernet networks, they're typically connected. They stay connected. That's the common thing. Wireless, we're in and out. Think of a hotspot at a coffee shop or a McDonald's. You sit down, you do what you need to do, and then you disconnect when you're done. Well, when you disconnect, your IP address, according to the DHCP server, is still assigned to you. So that's why in those situations we need to decrease the lease to an hour, 2 hours or so, because otherwise you can end up running out of IP addresses. So again, just to say, lease duration has a direct effect on traffic. Shorter lease duration, more traffic. Longer lease duration, less traffic. But a shorter lease duration also allows you to use a smaller number of IP addresses over and over again. DHCP servers and clients both rely on broadcast traffic in order to communicate, because prior to having an IP address, the only thing you have is a MAC address. And so you really can't take part in unicast traffic that requires a layer 3 protocol address. So they'll just communicate with broadcast, but that brings up an interesting point, because that means that DHCP server and client by default have to exist within the same broadcast domain. And what creates broadcast domains? Well, layer 3 devices. Typically routers, but could also be the layer 3 switch and VLANs that would not allow broadcast to go across subnet boundaries. All right. So the placement of a DHCP server is critical. Now, if the DHCP server is the router, well, then that makes it easier. But if it's not, then we have to make sure that broadcast from the clients can reach the DHCP server. So server on every subnet is the easiest to implement. Each server maintains its own range of IP addresses for that particular subnet, but that can be expensive. Again, these can't be just a client computer. If you are using Windows, it does have to be the Windows Server operating system. So that's typically not something we would do. We could also have a centralized server, a server that has ranges of IP addresses for all the network segments. But then how do we get the broadcast to it? Well, there's an RFC. RFC stands for request for comment. When you start getting into networking and IT protocols and technologies, they all have RFCs. There's usually very, very long, very, very boring, not something that we ever read. Okay, in this case, RFC 1542 described the selective forwarding of DHCP-related traffic on routers. Every router you encounter today should be RFC 1542 compliant. Basically, it means it can act as a relay agent. So it'll detect a broadcast and then it can forward that information directly to the DHCP server. Okay, DHCP relay agents function the same. It could be the same device. It could be another system that's just intercepting broadcast traffic and then forwarding it to a pre-configured DHCP server via unicast. Okay, so that it goes across the router. So anyway, just something to think about. Where they're placed is determined by whether or not broadcast can get to them. Now, DHCP is a very common protocol. It's supported on all major network operating systems as well as many network devices. So Windows servers, Linux servers, network routers, firewalls, access points, etc. The type of DHCP server is often going to depend on the particular type of environment. So your small office, home office networks will use either just the cable DSL modem itself or a wireless router to do this. Business networks will typically, from what I've seen at least, use Windows or Linux servers, or I should probably add network devices. Okay, a lot of the Cisco Meraki's is one that we consistently deal with. It functions as both firewalls and security appliances as well as wireless access points. Depends on what you're doing, but they have the ability to utilize DHCP, and they're configured from the cloud, which is a benefit too. Configurations are pretty similar to all devices. You'll have a web interface for network devices, and basically you're just putting in a range of IP addresses and then those additional options that you want to give out and possibly specifying the lease duration. You'll have a graphical administrative tool called DHCP, but it's the DHCP administrative tool for Windows servers. here's a look at that tool, albeit that this is a bit of an older graphic, but it still pretty much looks the same. DHCP servers do have to be configured in order to give out addresses automatically. So you have to, in Windows, install the role and then configure it. Okay, and the basic configuration is that you set up a scope, a range of IP addresses that the server is going to use to give out to clients. Now that range is just going to be like, 192.168.1.1 through 254, okay? But in reality, in a lot of cases, you've got situations where there are some static assigned IP addresses out there for servers, for printers, for switches, etc. Okay, and so, in that case, it's an exclusion range. You're saying these are IP addresses within this range of addresses, but I want to exclude them. I don't want you to assign them. Okay. On the other side of that is a client reservation. Slightly different. Client reservations are actually saying when this particular client communicates with this server, always give it the same IP address. So the client's still configured for to dynamically obtain an IP address, but we've told the server, hey, when this client communicates with you, always give them the same address. And we do that by reserving the IP address to a particular MAC address. So when this MAC address communicates, give it that IP. Okay, so you don't have to do both. You either exclude it and it's statically assigned, or you reserve it because the client is using DHCP and you want to facilitate the same address every time. The lease duration we talked about. And then you'll have additional options like router, DNS servers, any others, you can see over there, boot server host names, things like that. It just depends on the particular environment as to what you might need to set up. In this demonstration, we're going to look at configuring the Dynamic Host Configuration Protocol, DHCP. And specifically, we're going to do this on a Windows server. Okay, so I've actually this is a Windows server, and when you log into a Windows server from 2016 through the new 2022, you're going to get Server Manager that opens up automatically. So just a quick overview. This is really more of a monitoring capability. That has nothing to do with that, but this is a monitoring capability, and we can see alerts and whatnot. So if there are problems, these will show up in red. If they're good to go, they'll show up in green. You don't actually click on this to configure DHCP or to configure DNS or to do any of this. And it looks like it's all wanting me to restart. Okay, but what instead you do is you click on Tools and then you go to the Administrative Tools. So the first step, and I already did this, the first step is to install the DHCP role. And then when it installs the role, it also installs the administrative tools. And then the next step is to actually go in and configure DHCP. Okay. So and that's why, by the way, this is showing up like this, and it's telling me I need to complete the DHCP configuration, and it'll just start the install wizard. So I'm going to go ahead and do that. It's going to create a couple admin groups. It's going to authorize the server. All right. That still doesn't actually set up DHCP. So what we need to do then is we need to create a scope or a range of addresses that we are going to assign to client computers. Okay. Now I'm in a cloud environment, so I'm just going to be blatantly honest here. I can't fully test this out, because the cloud environments make it a little bit trickier to start changing IP addresses and things like that, okay? So I have a client machine that we're going to use for various labs, and I have a server machine that we're going to use, but we're basically just going to set up the server side of this. I'll show you how to go and check it on the client side. I'll show you how to get a DHCP address, but I'm just telling you, we won't be able to go the full way. Okay, so we're going to just call this some logical name, corporate subnet. And then we're going to come up with an IP address that we want to use, or a range of IP addresses that we want to use. Okay, so we'll try to make this as legitimate as possible here. So I'm using the 10.1.0 network, 24-bit mask. Okay, my IP address is 4, the default gateway is 1. We may have a couple of other static IPs out there. So I'm going to go 10.1.0. Was that? Yeah, 10.1.0. And we're going to have the starting range be, we're going to start at 50. A lot of times, instead of doing an exclusion, we just make the scope smaller. Technically, this scope is from anywhere from 1 to 254 in that last octet, but that doesn't mean you have to do that. Okay, and so I'm just going to go in and say I just want to go from 50 to 150 or 50 to 250. That gives me the ability to have 200 client IP addresses obtaining IPs from this DHCP server. That's the mask, and I didn't mean to change it. Okay, so it's 24-bit mask, and notice you can just put in the length, and it'll fill in the rest of the subnet mask for you. And then here's the exclusions. Exclusions are addresses within our range of address that we do not want the server to distribute. All right. In this case, I don't really need that because I went ahead and started the range up at 50. That already gives me 40 some odd, static IP addresses that this server will never give out. So as long as all my static IP addresses are in that first block of 50, I don't need to worry about an exclusion range. This is actually a delay in a case where you have multiple DHCP servers that are servicing one subnet, or then you might need to do a delay, but it's actually better said, if that's the case, if you've got two DHCP servers servicing one subnet, they really need to be configured to work together. And so we don't necessarily use the delay. The delay is sometimes useful when you're trying to migrate from one DHCP server to another. Okay, the lease duration, it's 8 days by default on a Windows server. You can make this whatever you want. As we discussed, the shorter the lease, the more DHCP related traffic, but the more IP addresses or the better you can utilize your IP address range. If you have a really long lease and clients do disconnect from the network, they retain that lease for the duration of it. And so in cases of wireless or any networks where people are coming and going frequently, then I probably want to shorten that lease time. Additional DHCP options, we're going to configure the router so that they automatically get their router. And then we're going to configure the domain name, which is testlab.local, and then myself as I'm the DNS server for that domain name. Okay. When servers are still listed, that's a antiquated option. We don't really use that anymore. And then do I want to activate the scope? I will need to activate the scope to be able to use it. I don't want to because I don't want this thing automatically trying to give out addresses. Okay. So it'll still show up as a red X, but I can still get in and I can see the address pool. I can get in and see any leases. This is a part that we will miss. We're not going to actually be able to see leases because I can't lease out the addresses and still retain connectivity. If you have the need to do reservations, you can go new reservation, give it a name. All you're doing is typing in a MAC address and then associating it with a particular IP address. An easier way to do it is to go to the address leases, assuming the client has already obtained an IP address. They'll be in this list, and then you can right-click that and you can make it a reservation. Okay. Scope options are those same options, and if you want additional options, there are a ton of them. Sometimes you need to do this for phones. Sometimes we need to do it for like automated installation options, things like that. Okay, I wouldn't worry about memorizing all of these. I probably would know 003 router and 006 DNS because those are kind of the two critical ones that we typically see assigned. A Windows server also has the ability to do IPv6 scopes, and so you could create a scope for stateful IPv6 configuration. All right, now I'm still on the server, but from the client side, if I do an IP config, this is all I'm going to see. Okay, so I don't actually see what I'm looking for. So go IP config all, and IP config all will show you whether or not you have DHCP enabled. Okay, and it will also show you who your DHCP server is. Okay, so note, again, my DHCP, this is a cloud environment, so my DHCP server is coming from the cloud service provider, and that's why I'm not wanting to change it, because it could mess up connectivity to this system. Okay, from a client perspective, easiest way to obtain a new IP address is just reboot. If you have a static address, let me show you that. If I have a static address, I'm going to need to go into my network connections. Okay, and this is really will suffice for Windows 10 and later. You go to Ethernet and change adapter options. Oh, you know what? It's probably not going to let me do this. Yeah, I'm going to I won't be able to do it, but it would change adapter options and going to TCP/IP properties and configuring it to obtain an IP address automatically. And I apologize, that's because, again, the cloud environment that I can't see that. Let's do this at least. Okay. Obtain IP. That way at least we'll give you the visual in case you haven't seen that. I'm hoping for a picture here. Okay, so this is giving you a couple of options, Windows 10, Windows 8. It's open, and you can do this. You can right-click down here and say Open Network and Sharing Center, and then we can go to Change Adapter Settings, TCP/IP v4 Properties. Okay, and then we tell it to obtain automatically, and usually we say to obtain a DNS server automatically as well. All right, so that's the key. Now, they'll be set up like that by default. Clients will typically be doing that already, but just in case you have to change it, that would be where you go. When you change that, it's automatically going to try to obtain an IP address. If you have a new server online or something, you can go ipconfig release, hit enter, and then once it releases the IP address, we can go ipconfig renew, and that will attempt to obtain an IP address via DHCP. If it obtains it correctly, then you should be able to go to the server and go to address leases and see it listed there. Okay. Now, as I said, there are other options, firewalls, wireless access points to give out DHCP addresses. We're not going to look at a lot of those, but that is fairly common as well, especially for smaller offices that don't have a server. If an office, at least in my experience, if an office has a server, a Windows server, then typically that server's running DHCP. But if they don't have servers, then it's probably, it's got to be the firewall or wireless access points that are giving out those IP addresses. So concepts are the same, exact steps are going to be a little different on, say, a Cisco Meraki, a SonicWall, a FortiGate firewall. They're going to be a little different in where you go, but, if you run into that situation and you haven't gotten training on that particular device, easiest way is to do an ipconfig all, figure out who your DHCP server is, figure out what that device is, and then, just go to the internet and look up some documentation on how to configure DHCP for that device. All right, final thing here, just to make sure, I'm going to go into services and we're going to shut off the DHCP service. I never activated the scope, so I don't think it's an issue, but I'm just going to go ahead and stop it because I don't really need it. Alrighty. Okay, so that's going to complete this demonstration. We wanted to take a look at how to install and configure DHCP. So the next network service that we want to look at is name resolution. We'll start by defining it. A name resolution is simply the process of resolving user-friendly names to numeric IP addresses, and that's just to make it easier for end users to communicate on the internet, communicate with remote systems, right? Nobody wants to try to remember the IP addresses. Some of the ones that we come up with for private, like 192.168, 1.4, 1.5, 1.6 for our servers. Well, I mean, if I'm using that, I can remember that. I don't necessarily need a name, but it sure would be easier to call them DC1, DC2, and DC3. Out on the internet, of course, the public IP addresses, well, those are all over the place in terms of like consistency. So who wants to remember 202.101.59.178? Like, you're not going to remember a number like that unless you are literally typing it on all the time, okay? So it stands to reason that we're people, we're humans, we want to use names, not IP addresses, therefore we need name resolution. Is name resolution technically required in TCP/IP? Well, not really, because you can communicate directly with an IP address. But name resolution sure makes things a whole lot easier, okay? And anytime a name is used, so you type in www.google.com, anytime a name is used, that name first has to be resolved to an IP address prior to you communicating. You know that for sure. If you use a name, that name gets resolved to an IP address. Now, name server assignment, DNS servers is what they're called. That can be automatic or manual. So you can statically configure, I want to use this name server, or we can have it configured through DHCP. Two basic types of names that are used by Windows hosts. Other non-Windows hosts will not use NetBIOS names, and even Windows hosts are starting to go away from this, but figure I'd still mention it. Host names are up to 255 characters in length. They are the same as the computer name. The computer name, along with the domain name, makes up an acronym or a term that you're definitely going to want to remember, and that's FQDN, Fully Qualified Domain Name. So, like in a local domain, if my local domain was called ptl.local and my server was srv1, it would be srv1.ptl.local. And a lot of us don't think about this, but when you go to, let's say, a web server, www.ebay.com, that's a fully qualified domain name. eBay.com is the domain name. www is the host name. Okay, now it could be an alias. Doesn't mean the server's actually named that, but still. Okay, same thing with a lot of mail servers. It'll be mail.companyabc.com. Well, companyabc.com is the domain name, and mail is the host name within that particular domain. We want to keep thinking that way. NetBIOS names are an older technology built into Windows, limited to 15 characters with the 16th character that identified the service. Still available. NetBIOS over TCP/IP is still available for backward compatibility. However, it's highly unlikely these days that you would ever have to worry about NetBIOS names. Will they be generated by your Windows machine? Absolutely. But are they ever being utilized? Not really. DNS has been the default name resolution since about Windows 2000. Okay. Now it's a bit misleading because even Windows XP and Windows Vista still had these ties in certain areas to NetBIOS names, but we're working away from that. So host names, DNS, those are really the ones you got to worry about. The DNS stands for Domain Name System. It's an application layer service and protocol that's responsible for resolving host names to IP addresses. It is a hierarchical distributed database. Okay, now that sounds fancy, but what it means is that there's no one server in the world that has all of the answers. It's not like everybody is hitting the same database for name to IP address resolution. No, instead, DNS servers host a particular portion of this distributed domain database. Okay, and so it jumped to the last bullet point. No single server has all the answers. Instead, servers are authoritative for particular portions of the public namespace. The top level is the root, and that's represented with a period. Then you have top level domains, com, gov, edu, net, info, biz, cc, go on and on we go. We have tons of them now, and those are called top level domains. Second level domains are the Microsoft.com, the Google.com, the eBay.com. Those are those that are registered to individuals or businesses through a registrar, okay? And a part of that domain registration is having a server that's responsible for name queries. Because when there's a query to www.google.com, it's got to be directed to the server that handles that particular domain. And this is just foundational knowledge. DHCP and DNS, just foundational knowledge in dealing with networking. Because we always need IP addresses, and we're always using name resolution, unless I deliberately use an IP address, okay? So understanding how this works is very useful for the test, of course, but it's also very useful on a day-to-day basis, and I can't really emphasize that enough. So part of registering a domain is going through a registrar, and that registrar really becomes your DNS provider in the vast majority of instances. Okay, so if I register a domain through GoDaddy, then GoDaddy is my DNS provider. That's where I can add records into DNS. If I register a domain name from Namecheap or fill in the blank with numerous others, that's who is my DNS server. Now, internally, we have DNS servers for internal domains, Active Directory domains, and that will be one of your Windows servers that will be responsible for that. So let's just deal with that on the internet. It's sort of easier to think. It's a hierarchical distributed database that consists of zones, which is nearly synonymous with domains, and records, which are individual entries that identify host. Every client's configured with a preferred DNS server. This is the one that they should query. All right, and they will query that server with requests for name resolutions. Now, the preferred DNS servers will either have the answer or they will go get the answer. All right, they don't have the answers for everything. Your internal server is what you typically use for your DNS, and it's only got the answers for a single domain, maybe 2 or 3, depending on the situation. You try to go to Google, you try to go to Microsoft, you try to go to anywhere on the internet, it's going to have to go get that information for you. It's going to have to find the name server that's responsible for that domain and then query that name server. But that is how it works. Your DNS servers will do that and go find answers. So within DNS, there's a lot of different components that work together to provide name resolutions. Some of these reside on clients, some of them reside on servers. Of course, the DNS server actually has a database. Database may be a bit of a stretch. I mean, that's what they call it, but a lot of times it's just a text file that consists of zones or domains and then individual records that identify individual host. DNS clients are just configured to send name resolution queries to a DNS server. The database stores the zones and resource records. As I said, it could be just a text file. If it is on domain controllers in a Windows environment, then it can be integrated into the Active Directory database. The DNS zone is just a specific portion of the hierarchical namespace that's maintained by a single server and has resource records for computers in that particular zone. So what are resource records? Well, there are multiple types of resource records. You will be asked to kind of explain what these are, what they're used for. The standard A record. The A record is also known as the host record. This simply identifies a name and a corresponding IP address. This is the most common resource record for you to find in a DNS database. PTR records are the reverse. Technically stands for pointer. I don't know why that means reverse, but okay. It maps an IP address to a name. Those are usually used by diagnostic tools, troubleshooting utilities, maybe some security, backend security, not generally required. SRV records, service locator records. They help clients look for a particular service. The most relevant example in a Windows environment would be clients looking for a domain controller to log in to the domain. So domain controllers will register the SRV records in DNS, and the client will query and say, hey, give me a domain controller for this domain. And then they will be given a record that has a name in it, and they'll turn around and ask for the A record. A CNAME is an alias. This is a pretty common one too, especially for internet-facing DNS. Because it allows us to associate a different name other than the actual computer name with this system. So pretty much anytime you see www, that's not the actual name of that server. Okay, if were you to go in and look at DNS, you would often find that that is a CNAME record, which then maps to a different name. So CNAME or alias. MX is mail exchanger, and that is a record that is used to identify the SMTP servers for a particular domain. So if I have mail to send to you, then I'm going to look up the MX record, and it will identify the name of the mail server. NS is name servers, that just identifies the DNS servers. SOA, start of authority, that's the first record in a zone, and it identifies the primary name servers for that zone. So there are a few others. There's the AAAA record, which is in the cloud there. That's an IPv6 record. There's also a TXT It's basically the IPv6 version of the host record, sorry. There's a TXT record, which is another common one that we will do. Sometimes text records are just added to verify domain ownership or verify, something or other. Text records are also used for anti-spam. So it's known as an SPF, or it's known as SPF records, but it's actually just a text record with a particular name. So those are a couple other common ones that we can see. All right, earlier I said the DNS zone is pretty much synonymous with the domain name. There are two kinds of zones: forward lookup zones and reverse lookup zones. Forward lookup zones contain name to IP mappings. That's the most common type. Now, I said it's synonymous. It could actually contain a single domain or multiple domains. It's really all about which servers are responsible for it. Okay, so for instance, look at the foo.com zone that has a sales.foo.com and an office.foo.com, all within that same circle. That just means one DNS server or a group of DNS servers manage name resolution for all three of those domains. Whereas research is split off into its own zone, so that's delegated to a particular name server. So it's all about spreading the load, decreasing the workload on a particular server. Reverse lookup zones contain IP address to name mappings. And those are in those pointer records, the reverse records. So most of the time we're creating a forward lookup zone. Most of the time a zone and a domain are synonymous, but it is possible to have multiple domain names within the same zone. So with the zone, just think of authority. If the domain is in my zone, then I'm authoritative. I can answer questions for it. So let's look at the process for name resolution. When a client tries to communicate with a name, like we see in this graphic, there are multiple steps that are used in order to obtain the IP address. And as we said before, the IP address has to be obtained before actual communication can occur. There are no packets on the network with names in them. Okay, so it's only IP addresses and MAC addresses. So the very first thing the system does is it looks at its own name, because it is possible that you're trying to communicate with yourself. Assuming it's not your own name, then it looks at what's called the host file. This is a local text file that exists on every machine, and it can contain static DNS entries. If there's a static DNS entry in the host file, it will be used, and a DNS server will never be queried. Just to kind of side note there. You also have the DNS client resolver cache. That cache caches both positive and negative information. So if it looks in the cache and it's not there, and then it queries a DNS server and gets the answer, it'll cache that answer for a given period of time. That time's known as the time to live. When that cache entry expires, then it will have to query a DNS server and update the cache again. Okay, so a couple of things there. I mean, that's really there for performance, so that you can quickly resolve names that you've already resolved to an IP. But it's key that it caches negative information as well, because if you attempt to do name resolution and it's unsuccessful, then your computer caches that. And if I go and try to ping or communicate with the same name again, it'll just bounce back and say, nope, it's not accessible. That's key, because if you do have DNS problems, what you typically want to do after you think you've fixed it is to flush that DNS cache. And you can do that with ipconfig/flush DNS, or we can do that in Windows PowerShell in the newer versions of Windows. The final step, as we said, would be to query a DNS server. So number one, am I trying to communicate with myself? Number two, is there anything in the host file? Usually the answer to both of those is no. Number three is, do we have this information already cached? If so, yes, use it. If not, query a DNS server. Once we get the response back, we'll cache that for future use. When resolving names of internet hosts, the DNS server is actually going to take on most of the workload. There's two types of queries that can be sent, a recursive query and an iterative query. A recursive query is typically, and we should just say this is always default, but this can be changed, but a recursive query typically is sent from client to server. It's saying, give me the complete answer for a particular domain name. Okay, don't give me a forwarder. Go find the answer for me. And so the DNS server is not responsible for the domain that you're asking for, so it goes to the root servers on the internet, which then I passes the IP address for the top level name servers on the internet, like com, edu, gov, etc. And then that would pass information for the server that's actually authoritative for a particular domain. Those queries from server to server are iterative queries, where they will accept the best answer. If not a complete answer, they will accept an answer, a forwarder to the next server down the hierarchy. In this demonstration, we're going to look at configuring DNS. We've talked about the domain name system and how it is utilized to resolve names out on the internet as well as names on an internal network. So Windows networks use Active Directory and it's integrated with DNS. That means DNS or Active Directory domain names are represented by the local DNS server. That allows clients to join the domain and it allows them to query using fully qualified domain names within the network. And then, of course, we use DNS out on the internet as well. All right, let's start this way. Let's open up Windows PowerShell prompt here. The command line way of doing this would just be to say ping and then put in a name. Okay, so ping www.microsoft.com. Okay, and you can see it is pinging, and then it even says, okay, that looks like that was a different name, but here's the IP address that maps to, and then I get responses from that IP address. We try a different name like CompTIA.org. Okay, notice almost every time when I say ping or when I say www, it's going to give me a different name. That's because www is actually an alias. You don't actually have a server that's named that, but this is the name of the server. Now, in this case, it timed out, which is fine. ICMP is the protocol that ping is using, and that is sometimes blocked by the destination or some device along the way. But that's not really what we were concerned with here. We were concerned with, did we get an IP address? Okay, so name resolution worked correctly because we've got an IP address. All right, now while we're here, let's go ipconfig display DNS, and that's going to show me my cache. Okay, so I can actually see, looks like we've got some other stuff in here as well. I was trying to find the ones that I had just pinged. And you're going to see a lot of stuff. So, I mean, these days, there's so much going on with the client operating systems and even a server operating system that it's connecting to the internet and doing things behind the scenes that you didn't even know. I was really just trying to see, and I'm still not noticing that specific one. Okay, so ipconfig display DNS, ipconfig flush DNS is going to flush the DNS resolver cache. There are PowerShell equivalents to both of those. That is get DNS client cache. That would display it. Okay, so now if I ping www.microsoft.com, we'll get a response. If I then say I want to get client cache, there we go. Okay. And I like the PowerShell version because it's a little bit cleaner. The other one goes on and on and on, but that's the idea is I just cache the information because it was successful. Here's the time to live. Okay. And that time to live has already elapsed. So when I run get DNS client, it's already gone. So the next time I communicate, and maybe that was the problem, the next time I communicate, I'm going to have to query again. So the time to live on that one appeared to be very, very short. So get DNS client cache, clear DNS client cache is the PowerShell equivalent. And then in PowerShell, you have a resolved DNS name, and you can put in something like, we'll just do CompTIA.org again. Okay, and then it will actually resolve it. And it'll tell me it queried for an A record. Okay, I'm sorry, it'll tell me it queried for this, and it got a CNAME record. And in the CNAME record, it directed us to that. I queried for that. It was another CNAME record, and it gave me this. And then finally, that is the A record that I got and the answer and the IP address that it goes to. Okay, so I like PowerShell's way of kind of laying that out a little bit better. If you open up on your own machines, if you right click here, you may not see this. You may see command prompt. So you either click here and type in PowerShell, okay, and open it that way, or you can actually open the command prompt. We'll check this out. You can actually open the command prompt and just type in PowerShell. And then you'll have access to all the PowerShell commands, what you're looking for. So as long as that says that, you're actually in PowerShell. PowerShell is going to be more capable than the straight command prompt. And if they're not already doing it, they're going to start asking about it. And they should be on these exams. Even if they don't ask, it's definitely something you want to know from a real life perspective. Okay, so that's really just kind of showing the client. I've also got PowerShell, I've also got DNS installed on this machine. Vast majority of the time, if a machine is functioning as a domain controller for Windows, an Active Directory, it's also going to be a DNS server. So here's a look at an internal DNS server. This is my internal Active Directory domain name, okay? testlab.local. These are just kind of defaults. This has to do with Active Directory, so you don't need to get into that. You've got your start of authority record, which is the first record in the zone, and it identifies the server that's authoritative, okay? You'll also have a name server record, NS record, for each DNS server. And if there are more than one, then you'll see more than one NS server. Usually have this one. When it says the same as parent folder, it just means there is no actual name. So if there is no name, then it's associated with the domain name, right? So if I were to ping testlab.local, I'm actually going to get a response from myself because of that record right there, okay? So it's an empty record. So here's a couple of other, this is my domain controller's A record. This is my client machine that's a member of my domain that we haven't gotten onto yet. You know, those registrations will happen automatically. Other records you have to create manually, okay? So like aliases, CNAME records. If I created a www record, I'm saying, okay, if you go to www.testlab.local, that's actually supposed to point, and then you go and find the A record that you want to use, okay? And so this is what often happens. They create these records so that I can resolve DNS name, www.testlab.local, and I'll get the answer. Notice the answer is a CNAME, and it pointed to that host, and then it queries that host, and it got an A record, and there's the IP address. Okay, all because I added that in there. All right, now your internal servers can only answer questions, and any server for that matter can only answer questions for the zones that it has. So when I make a request, as I did before, to resolve a DNS name like www.google.com, my server had to go out and get that information. If I go to the properties of my server, it can be configured with forwarders. That means it would forward all unresolved queries to a particular IP address. Or more commonly, they're configured with root hints, which is the IP addresses of all the root name servers out on the internet. Notice the vast majority of those are now using IPv6. So the root name servers on the internet, and it goes, and the root name server will point me to the top level domain server and then the second level domain server until I find the server that actually has the answer. Okay, so the point here is the DNS server is actually set up to go out and get information from other servers on the internet by default, so long as it has an IP address. As long as it's got an internet connection, I should say. Okay, so that looks at that internally. Again, there's a lot more you could talk about, but that gets you an introduction as to how DNS works, how the cache works. Let's go, actually first we're going to flip over to the client machine. All right, so here we are on our my Windows 11 client machine. Windows 11, it calls it the terminal, but it's still PowerShell. Okay, so we can do resolve DNS name Microsoft.com, and I'm going to get the same kind of information over here. Okay, I'm just going through a server. So if I go ipconfig all, it's going to show that my DNS server is that domain controller. All right, and you can obtain that via DHCP scope options, or you can obtain that, or you can have it set up manually. All right, in this case, it's set up manually, but regardless. Okay, so that shows that same clearing cache and whatnot is going to be the exact same if you're on a client machine. So really the one reason I wanted to go over here is just to show you that host file, because until we see that host file, it doesn't often make sense. I'm actually going to open up Notepad, and then you need to open it up as an administrator. Okay, and then we're going to go File, and we're going to just go and type in the location. Okay, so C, Windows, System 32, drivers, etc. You'll have to switch this to all files. These files don't have any file extension, so there's a host file with no file extension in the C, Windows, System 32, drivers, etc. folder. Okay, this file contains a mapping of IP addresses to host names. If you want, okay, I'm not saying you have to do this, I'm just showing the functionality of this. Okay, if I want, I would go like this, 10.1.0.4, which is my server, and I want to just call that, I don't know why it keeps doing that. Here, let's go. I just want to call that my server. 10.1.0.1, I want to call router. Okay, and this is just an example. We're going to hit save. Okay, and I want to show you a couple things here. First, we're going to clear the DNS client cache so we know that it has nothing in it. Okay, then I'm going to get the DNS client cache. Command line equivalent ipconfig display DNS. Now notice, in that cache, there's already a couple of records. So basically, even clearing the cache, the host file puts those entries into the DNS client cache. And if I go ping router, it's going to try to ping it. Now, I may not get a response, and I didn't, but it still resolved the name, ping my server, and it's still going to resolve the name, and in this case, I will get a response. So that just shows you that DNS client cache, it actually supersedes the DNS server queries. If you have something in the cache, you will never query a DNS server. That's why it's always a good idea when you're troubleshooting something with DNS, very first thing you should do is ipconfig flush DNS, and then ipconfig display DNS. It's a real quick and easy way to tell if you have things in your host file. Okay, now I use the PowerShell equivalents, but it's the same kind of thing. All right, now we also have public DNS. I'm going to show you, we're going to go to mxtoolbox.com. Now this specifically is for looking at things related to email delivery problems, but it works for anything. So careeracademy.com, and we'll do an MX lookup. That's going to look up the mail exchanger records that identify the host. And this one's going to outlook.com. So it looks like that is, they're probably using Office 365. That's what we see a lot. But notice we can click on here and we can look for other things like the SPF records. The SPF records identify the hosts that are available to send. Okay, and so again, they're using Outlook, they're using Office 365. So from an anti-spam perspective, that's what it's looking for. You can look for other things, regular A records, DNS checks, whatever. Point is just simply you can go through here, plug in a domain name, and you can see how a domain is hosted and view some of the records, in this case particularly related to email. Okay, we're going to go to GoDaddy.com. That's one of the main registrars. A lot of companies use GoDaddy. A lot of companies may use something else, but I'm just going to sign into one sample account so we can see how to do this in a public DNS server. Oh, might take that back. That's not going to allow me to do that. Okay, here we'll try one more, and then we may not be able to do that. Sometimes when you're coming from a different location, then it's requiring multi-factor, and these aren't actually mine. Yep, it's still trying to do the same thing. So anyway, I was just trying to get into a public DNS provider. Not really that big of a deal. They're all going to be slightly different, but what you're looking for is to get into the management of DNS zones. And then you'll have the ability to create A records, C records, TXT records, MX records for mail, those kinds of things. So I was trying to get into a public provider, and I apologize that I'm not able to get into those just because those aren't mine. I was just borrowing them for the case of this demonstration, and so I can't complete the multi-factor. All right, so we looked at DNS on the internal network. We saw the functionality of the DNS cache and the host file, how to validate your DNS server from a client perspective. All of those things are going to be very helpful because remember, for the vast majority of network communications, the very first thing you need to do is resolve a DNS name to a numeric IP address. In this next topic, we're going to be looking at wireless implementations. Wireless technologies have become more and more advanced over the years. Obviously, they have a lot of advantages, and this is why people utilize wireless so much, not just in home environments, but as well in business environments because of the portability of the devices, the flexibility of connectivity, the anywhere access, if you will. But behind the scenes, there are several components that are required. There are different technologies that are utilized. There are various speeds that you're capable of. And so, being networking professionals, we can't just bland or just vaguely use the term Wi-Fi for everything. We need to understand what the differences are and how you set it up. So let's start with some fundamentals. A wireless LAN or WLAN is just a local area network that uses radio waves or possibly in the past, at least, infrared light instead of wires, instead of cables to connect computers or devices. So the connections still require a network interface card. It's just a wireless NIC that has an antenna as opposed to a connector, like for an RJ45 connector. And the antenna is then used to use radio signals to send and receive data. Wireless devices can communicate directly with one another, that's called ad hoc mode, or through a wireless access point, that's referred to as infrastructure mode. With access points is by far the most common, which we've already talked about, and they would interface with a wired network. If nothing else, just interfacing with a cable or DSL modem to provide internet connectivity, so the access point is acting as a hotspot, right? But it's still infrastructure mode. Anytime you have an access point, you're in infrastructure mode. Ad hoc is direct computer to computer. Now, lots of advantages, portability, flexibility, we talked about that, distance, ranges, things like that, can even be outside and still connected to the network. The disadvantages, though, are primarily related to security. Okay, the longer that signal can exist, the more likely somebody could tap into it. The simple fact that somebody doesn't actually need to physically be in your building to connect to that wireless network should basically speak for itself, right? And just, I don't have to be connected at all physically, right? I just have to be wirelessly connected. So we need to take extra steps in the area of security. So continuing on with fundamentals of wireless LANs, they've become a staple in virtually every network environment because of the advantages. Reduction in cost, I hadn't mentioned, but that's the lack of, we don't need to run cables. Okay, we can just set up a couple of access points and connect that way. So obviously increased flexibility. Support for more mobile workforces. that generally when wireless first came out, I mean, that was pretty much just laptops and maybe your occasional smartphone. Now we've got smartphones, tablets. Everybody's got, it seems like, a couple of computer systems essentially on their person at any given time. And so you've got a lot of increased flexibility, mobile support, and it also provides the ability to have guest access. So we can make it easy. Somebody doesn't have to wire in, but they can connect to our network maybe for some guest access to an application or guest access to the internet. Now, wireless networks can be broadly classified into signal types. How is the wireless signal transmitted? Radio frequencies are going to be by far the most common because you and I typically, when we think wireless, we're thinking Wi-Fi, which is a very particular type of wireless connectivity. Okay? It's not the same as infrared. Infrared was never termed Wi-Fi. Infrared is a line of sight. Radio frequencies are not line of sight. Microwave is also not Wi-Fi. That's also a line of sight technology. Microwave would be used for broader wireless LANs or campus area networks where we have essentially wireless antennas that are on the top of buildings and have line of sight to other buildings around the campus. And then cellular, of course, now we're all familiar with cellular because of our cellular phones, so we have wireless access on those cellular devices. I have this not argument, not debate, I don't even know what the right term is, and I'm sure some of you, if you're just getting into networking, you've thought this same thing. But because their phone is sitting there and it's spinning and it's not doing anything, and they say, well, I have Wi-Fi. No, you don't. On your cellular device, you're not using Wi-Fi. You're using a data connection that is going to cell towers. That's a different thing. If you turn your Wi-Fi on and connect to a wireless access point, now you're on Wi-Fi. All right, so they are different signal types, and you and I on a daily basis are going to interact with 99.9% of the time radio signals. Okay, not infrared. That's older and has issues with line of sight. Microwave is for a very particular implementation, and I suppose we'll interact with cellular on a day-to-day basis as well. But when we talk about setting up business networks, we're not talking about cellular data. So let's go through these types of wireless. In a LAN scenario, it's always either going to be radio, infrared, or Bluetooth. Radio is Wi-Fi. All right, wireless fidelity is what that actually stands for. Maybe that'll answer you a trivia question one time. I've always said that jokingly, and then I was at a trivia night where they actually did ask what Wi-Fi stood for, and I thought it was kind of hysterical. And I got it right. Wireless fidelity. Now, as to why that name is like that, I don't know. But what we call Wi-Fi is going to be radio frequencies typically sent from, in infrastructure mode with access points. It's not line of sight technology, so you don't have to be pointed directly at the antenna or anything, but it is susceptible to distance limitations and interference. Having said that, the latest and greatest Wi-Fi technologies, distance limitations are typically in the hundreds of meters, and the interference has become less and less as we have kind of evolved over these different technologies. Technically, radio is offered in both local and wide area connections. Now, typically, we don't see it in wide area connections, but there are radio frequency ISPs that are out there. I've not had good luck with them, but then again, it was a decade ago or more that I ever interacted with one. It was very slow, but in certain areas, especially rural, you might have that option. Infrared is line of sight using pulses of infrared light to transit signals. Relatively low speeds, 9600 BPS up to a whopping 4 megabits per second. This was standardized as IRDA, the Infrared Data Association. But that's sort of a history lesson at this point. Okay, infrared works great for remote controls. It does not work great for networking. Bluetooth is another type of radio frequency, but it's very short distance radio. I think the latest Bluetooth standards are only like 30 meters, if that, and so primarily this is for mobile devices, right? It's for your car stereo, it's for headphones, it's for speakers to be able to connect, but they're relatively within close proximity to one another. Bluetooth and Wi-Fi are not synonymous. Let's look at the different components that we've got. First component would be a station. It's just a term used for a client that connects to a wireless card. It contains an 802.11 interface and a MAC address. What is 802.11? Well, that's the IEEE standard for anything and everything Wi-Fi. So definitely recognize that number, as it might be used as a synonym to Wi-Fi. It's just another name. You're referring to the standard. So a station is any node with a wireless interface card. Today's laptops will all have wireless NICs. In fact, some will not even have a wired NIC. In the past, it's possible that you had to extend your laptop to include that capability, but that's going back quite a bit of time. Desktops do not typically include a wireless interface card unless you choose to include that. But those can be added via USB or PCI slots. They're connected to the wireless access point. That's the device that provides the connection between the wired and wireless network. Wireless access points use what's called an SSID, or service set identifier, which is just a name that uniquely identifies that wireless network. So when you and I click to want to connect to a wireless network, we will see the SSIDs in our general vicinity. We'll be able to choose one and then make an attempt to connect. Now, in business settings, you can have a service set. This defines the way the wireless LAN is configured. A basic service set, or BSS, is just one access point. And so that's what most of us will deal with. In some cases, though, you will have multiple access points, and this can be referred to as an extended service set. This would be one of those situations where we put in multiple APs with overlapping coverage ranges, and we use a wireless LAN controller in order to centrally manage them. So just keep those acronyms in mind as you might see those on the exam. In this demonstration, we're going to look at just a general configuration of a wireless access point. For this, I do have to use my kind of home access point. So this is a Netgear Nighthawk that I have at the house, but it'll give us some of the basic configuration, okay? So first of all, we could just kind of jump through. I guess we'll start on the home screen. Is just a bunch of tiles that tell you if you're connected to the internet. You want to get into wireless settings, see the devices that are connected, turn on a guest network, security, things like that, okay? Or you can just go down through these categories. Obviously, every access point is going to be a little bit different, but there's also going to be a lot of similarity as well, okay? So most of them will have some sort of internet setup that is by default. This, you can choose your WAN preference. Does your internet connection require a login? If so, what's the name and password? Obtain automatic IP address, or use a static one. Typically for home networks, that's automatic. For business, it might be static. The MAC address, in the old days, you sometimes had to mimic the computer's MAC address in order to actually be able to get connected. That's usually not the case anymore. Okay, so that's just the internet settings. The wireless settings are going to allow you to configure the wireless networks themselves. Okay, and in this case, this is a router that supports a lot of different standards, all the way up through AC, I believe. And so for each, we can say, okay, yes, I want a 2.4 BGN for backward compatibility. I call it Westlake 24. We can choose the channels and the power controls, and then we can choose the mode. Okay, and then we've got the security options, WPA, PSK. We'll talk about those a little later. Here's the 5 gigahertz. Okay, this is what I want to call that. This is what channel to use, etc. Speeds, and then the same thing on security, passphrases. There's a couple of, with A and AC, or N and AC, you have the ability to do different SSIDs because it's using the multi-input, multi-output. Actually, it's MU-MIMO for those later versions, and so we can have advanced capabilities there. But same kind of deal, network keys for all of those. Attached devices, we're going to be able to see the different devices on the local network that are connected. These are going to be, different smart TVs, laptops, and whatnot. We've got quality of service. So if we want to enable quality of service, we can allow, we can do that. It's basically just going to optimize performance for certain types of communication, parental controls, setting up a guest network. I don't have that, but this is something that we should definitely do at businesses, where we allow for a guest network just to get access to the internet and nothing else on the network. Okay. And then we have the advanced. I mean, you're going to have other types of things. It's just router information, internet port, just links to each and every one of these. You can go to advanced setup. With advanced setup, this is where we would configure things like port forwarding. So if I wanted to be able to remote desktop from somewhere else through my router, I would actually need to set that up. I would likely need a static IP address as well, but you could try. You are going to have a public address, but notice that's actually not even a public address. So that's an address that is for the particular ISP. Bridge mode, router IP, if you actually want to function just as an additional access point in an existing network, you can do that. Dynamic DNS is a way to make sure you have a name associated with your router. Okay, it is a service that you have to subscribe for. Turning on VPNs. VPNs are supported by most of these routers. Okay, and so it'll tell you how to enable that, and then you can get information on how to connect. That would be another method of connecting to this, from an alternate location. If you want to use IPv6, set up remote management, those kinds of things. See logs. I mean, again, every router is going to be a little different, but you just kind of go through yours. The easiest way to figure out what your router is by doing an ipconfig all and looking at your DHCP or your gateway. May not be your DHCP server on a home network. It probably is, but it's definitely your gateway. And if your gateway and your DHCP server are the same, then that's likely your router. Open up a browser and just go to it. Or if you have problems with that, then you kind of look up information on your particular router. All right. So again, that's just one example of, at wireless access points and how to configure them. It's more of a home setup here, but still is going to be useful for us to just kind of understand all the different features that are available. So we've mentioned wireless modes a couple of times. We'll introduce a third one, but as I said, this almost seems to me to be a moot point. I mean, you've got ad hoc networks where you're connected directly between laptop A and laptop B. I mean, they show 4 connected. Technically, you can have more than just 2, but these are pretty rare. They would just be used if you needed to use wireless to do data transfer. Typically, you got to have software on your machine that's going to allow you to set that up. Okay, it's not the same thing as a hotspot. Infrastructure mode, you're connected to an access point, and the access point is connected to a wired network. And then a mesh could be a combination of the two, essentially. You can have multiple wireless connections active at any given time. And so if you're in a mesh, that's what that would be. Now, all devices are capable of utilizing a wireless connection, provided they have a wireless NIC. The most common types of devices are truly portable: smartphones, laptops, netbooks, tablets, gaming systems, media devices, meaning smart TVs, those kinds of things, any of your smart speakers, all of that. So we kind of just assume that all of those are wireless. And really today, other than a desktop computer, I mean, we assume just about any device we have is going to have an embedded wireless transceiver and have the ability to communicate over a wireless network. So the IEEE has developed standards for wireless networking, including Wi-Fi, Bluetooth, and WiMAX. WiMAX was a metropolitan area network and wide area network standard, 802.16. You actually don't need to worry about that one now. I think that kind of never really picked up, and they've left it off the objectives. But 802.11 is everything related to Wi-Fi. Okay, there are going to be different variants: 802.11b, 802.11a, 802.11g, and we'll talk about those. But they're all in the 802.11 family. So that's Wi-Fi. 802.15 is the IEEE standard for Bluetooth. All right, so here are those 802.11 standards. The original standard was actually just 802.11, but it was not widely adopted at that point. So the first one that we usually think of is going to be 802.11b. Speeds up to 11 megabits per second, and it operates on the 2.4 gigahertz frequency range. Because of that, it caused a lot of interference issues. Microwaves, electrical equipment, cordless phones that were the 2.4 gigahertz phones, that would cause all kinds of interference with those devices. So that was potentially a problem, and actually that's why 802.11a was introduced. Even though it's odd that A comes after B, but that's the way it was. 802.11a increased the speeds up to 54 megabits per second, although generally speaking it was about 20 to 25 of what you actually got. They also changed to the 5.0 gigahertz frequency, which eliminated interference at the time. Well, then they came out with 5 gigahertz phones. So 802.11a did still operate better and with less interference and with higher speeds than 802.11b, but the one big caveat was that it wasn't backward compatible. And that proved to actually be the downfall of 802.11a. You very rarely saw systems with only 802.11a adapters. It would be an 802.11a, B, and even ABG combo adapters because A was not backward compatible. 802.11g was introduced to replace the B version and also provide an alternative from the A version. So it also operated at the standard up to 54 megabits per second, operating at the 2.4 gigahertz range, just like 802.11b, and so therefore it is backward compatible. 802.11n, 54 megabits per second, all anywhere up to 600 and beyond megabits per second. It can operate at the 2.4 or the 5 gigahertz range. And the way that it achieves the additional bandwidth is through MIMO technology, multiple input, multiple output technology, essentially multiple streams of data to increase throughput. Then you have 802.11ac, 400 to 800 megabits per second minimum with maximum rates beyond 1 gigabits per second. It extended MIMO technologies, has some additional modulation types, such as how the frequencies are modulated, and it operates at the 5 gigahertz range. 802.11n was officially called Wi-Fi 4. 802.11ac was Wi-Fi 5, and the latest one is 802.11ax, otherwise known as Wi-Fi 6. Okay, it does have the ability to operate on either the 2.4 gigahertz or the 5 gigahertz frequency range, and increases our speeds as well up over a gigabit per second. Now you can dig into these technologies to see all of the differences between them. That's not really important for the purposes of the exam. It's really just recognizing two things: speeds and frequencies. All right, now we mentioned MIMO. All of them, Wi-Fi 4 through 6, use varying levels of multiple input, multiple output. It's the use of multiple antennas in order to increase throughput. It's an essential element in these latest technologies. A multi-user MIMO, MU-MIMO, that's a mouthful, is used by 802.11ac and AX and is a more advanced version of the technology. Again, it's, you don't need to know anything more than we're going to start to see wireless cards with multiple antennas. Each of those is a separate connection. Therefore, we can increase the throughput for those wireless networks. All right, now we mentioned private or security, it being one of the primary disadvantages with wireless networks, and something that we need to at least be aware of. We don't want just anybody to be able to connect to a wireless network, just like we don't want anybody to be able to connect to an Ethernet network. The difference is with Ethernet networks, you actually have to walk into the building. You have to plug into a jack on the wall. Somebody's probably going to notice you in a conference room plugged in if you're not, it's not, known who you are. So that's what we have with Ethernet. With wireless, we don't have that. Okay, we didn't really go through the ranges, but I'm saying the ranges are, you know, in hundreds of meters sometimes, depending on the environment and anyone else's level of interference and things like that. So we have to put in place some security mechanisms. We have to be able to verify who's trying to connect. The very first one of these was Wired Equivalent Privacy, WEP. The name seems to imply that this is the equivalent to the privacy that you would have on a wired network, which is a joke, okay? And it's long been seen as that. WEP is really no longer used, so we're not going to spend a whole lot of time in detail on this. WEP encrypts data across the wireless network. It also uses a shared secret key and an RC4 encryption algorithm. 64 to 128-bit encryption. The problem is the RC4 algorithm is pretty. It's well known. It's an older algorithm, so it's very vulnerable. The keys have to be changed manually, and it's vulnerable to what they call IV attacks or initialization vectors. Okay, so you can use. WEP can use TKIP for additional security. That's just a different protocol that we'll talk about. But the fact remains, it is highly unlikely for WEP to be the right answer to a question. Okay, unless the question is asking which of the following protocols should you not use. So it's highly unlikely for it to be the correct answer to the question, and you should never, I repeat, never be using WEP unless it's the only option that you have available. And I'm going to follow that statement up and say, if it's the only option that you have available, then you are probably dealing with wireless equipment that is 10 to 15 years old. Probably time to get some new equipment. Okay, so this is more of a history lesson. Wired equivalent privacy should not be used any longer. Somebody who knows what they're doing and with the correct programs can get into your network in a matter of minutes. Wi-Fi protected access was created with the goal of replacing WEP, increasing security. You have two versions, WPA and WPA2, both effectively standardized as 802.11i. The original WPA uses the temporal key integrity protocol, which causes encryption keys to be changed at set intervals. WPA2 uses a different CCMP and the advanced encryption standard, which they're more secure without getting into the nitty-gritty details, which we don't necessarily need to. Both of these, WPA and WPA2, by the way, WPA is considered antiquated as well, so we should be using WPA2 or beyond at this point. But both of them have a personal version and an enterprise version. The personal versions are the ones that we're familiar with because most of us, when we connect to an SSID, are familiar with the concept of typing in a passphrase. That passphrase is not the key itself, but secures the shared secret key. And so by putting in the correct passphrase, then you are able to connect to the network. Pretty simple connectivity, but decent security. Enterprise versions have more advanced security, and that enterprise versions can utilize something known as 802.1x, which is going to basically have your access points forward the authentication request to a central device. That could be a domain controller, that could be a firewall, something functioning as what's called a radius server. And then that device determines whether you can connect. Well, in so doing, you can actually allow people on your network via their domain user account or via certificates that identify the device itself. So you definitely have a higher level of security with enterprise. Probably the most common security that you'll see today across multiple network types would be WPA2 personal. So 802.1x, as I mentioned, is recommended for enhanced security on business networks. Instead of the wireless access point being the performing the authentication, and really only performing the authentication of the passphrase, instead it allows the wireless access point to be configured to forward things to a radius server or authentication server. In so doing, the Radius server can have policies that require additional authentication methods like smart cards, token cards, certificates, Kerberos. We can require multi-factor authentication just because the access point's not the one making the decisions. The access point gets a connection request. It sends the connection request to the Radius server. The Radius server then has policies that determine exactly what we're going to require. Okay, Radius is a standard protocol that is that's used for remote access and beyond. Technically, Windows XP and later support 802.1x. The wireless access point needs to support 802.1x. That's sort of an antiquated statement. We really shouldn't have that problem these days. The vast majority, if not all, access points will support functioning as a Radius client. All right, so in our previous demo, we kind of saw a few things we hadn't talked about yet. Now we're going back and looking at them. So I want to focus in on the security a little bit, okay, just to show that you do have all these various options that are available. So when we go to wireless under each of these networks, notice I had 3 options. My router personally no longer even gives me the WEP option, but some of you will have the WEP option. Or you'll have the WPA with pre-shared key, or I'm sorry, AES, or with TKIP plus AES. So this is the original version was TKIP, Temporal Key Integrity Protocol, that manipulates the keys, and then used AES as the advanced encryption standard to actually encrypt. Both of these, if they say PSK, that's how most routers identify the personal version. So if you want to set up an enterprise, then you would select enterprise mode. Okay, then we can choose encryption levels, but that's probably, yeah, okay, we don't care. It's just saying it's not going to work with the WPS, which is sort of like an easy way to connect to a router. All right, so in this case, if you're choosing enterprise mode, you're going to hit the drop down and you're going to choose what you want. So I'm just going to say only WPA. And then I'm going to put in the IP address of a Radius server. Okay, the Radius server would be a server on my network that's running possibly network policy services in Windows. It could be some other network device, some Cisco device that is functioning as a Radius server as well. Okay, but what I'm saying is I'm going to forward all of my connection attempts to this machine. Okay, it's on port 1812, which is the Radius port, and then here's my shared secret. And the shared secret and the client has to be configured on the Radius server as well, along with policy settings. Now, we won't go through all of that, but I'm just saying even this home router is capable of using WPA2 Enterprise, which utilizes 802.1x and Radius in order for you to centralize that security. Now I'm just going to cancel it. I'm not going to make that change. I don't actually have a Radius server on my home network. Go figure. And so we're not going to do that. But those are really the main security settings. I mean, we need to configure a passphrase. My passphrase is not the greatest, but it's a home network and we're not overly concerned with security. Okay. But we need to, so we would like to have a more secure passphrase, and we definitely want to always be using the maximum level of encryption that we want, that we have available to us. The only reason that we're using this here is because this is the backward compatible one. And sometimes we get phones and old tablets and things like that they can only, and even some, I think a couple of our TVs, only will connect to the 2.4 gigahertz. That's the only one that they see. So that's why we drop it down and use level 1 and level 2, just in case those devices are not compatible. So anyway, those are the configuration settings. That's going to look very, very similar. Regardless of what type of router you have, you're basically just going into the SSID and configuring security. You know, one thing I didn't mention was the disabling of the SSID broadcast. That doesn't disable the wireless network itself. It actually just prevents the access point from advertising that network. And so in order to connect to said network, I would actually have to know the name of it. Okay, whereas usually I just click I just click down here, and any of these wireless networks that are around me are going to show up. I'm going to see my own. I might see a couple of my neighbors. Those aren't mine, but that's because they're broadcasting their SSID. If you're not broadcasting your SSID, then you don't show up in here, and you actually have to say that you want to connect to a hidden network and type in the name of the hidden network. So it is security. It's a small piece of security, but it is something. And I should have mentioned that now that we're doing the demo here with security options. I thought I would. So you do have the option of disabling the SSID broadcast. Don't only do that. Certainly still use the security protocols that you have available to you. Now, in some scenarios, configuring a wireless network is as easy as purchasing a router and turning it on. Basic configuration is provided by default. A lot of times we just plug it in. Or if I have to do something more than that, it's often an easy-to-use setup wizard. But there are more options that are necessary in larger scenarios. And one of the first things that we need to think about is how many access points do we need in a business environment, and where should they be placed? Okay, now I've run into this in a couple homes as well. They're larger homes or older homes with a little bit more solid, and a wireless signal doesn't carry from the upstairs corner to down in the basement. It just simply it doesn't. The signal's not strong enough. In those cases, we've put in not secondary access points. In a sense, I guess they are. They're called network extenders, and it's more like a wireless bridge, or repeater, just extending the signal so that it goes further. That's not what we're really talking about here. We're talking about a step beyond in business networks where this wireless coverage area is, let's just say, 200 meters. It's not going to be enough to span the entire building. Think big manufacturing, warehouses, larger enterprise buildings, those kinds of things. So we need multiple access points, and then we need to figure out where they need to be put, because we want the coverage areas of these access points to overlap so that there aren't any gaps, so that somebody doesn't lose connection if they happen to be walking with their laptop from one area of the building to another. Another element to that planning is the choice of antenna. The wireless antenna converts the signals contained on wired cables into frequencies that are understood and received by wireless clients. The antenna is used to send and receive radio waves, and that, on most networks, has a direct effect on the performance of the network and the coverage area. So here's just a couple rules. The larger the antenna, the greater the signal. Right? So on laptops, we don't even see the antenna. It's usually in the screen or in the lid. On desktop computers, you got an antenna that, if on your NIC, that's about 4 or 5 inches at most. Routers may have slightly larger antennas. We're actually talking about the antennas typically that are on the access points themselves. So in general, the larger, the greater the signal. The direction and type will also have an effect. The direction it's pointed, whether it's unidirectional or omnidirectional. Gain is the increase of the amplitude of the radio wave. That has both positive and negative effects. Positive, the signal goes longer. Negative, it could have more noise. Okay, so typically it's the higher the better, but if you exceed limits, it could also cause problems. There are 2 types of antennas that are specified on the objectives, the directional and the omnidirectional. Directional antenna is a type that concentrates the single beam in a single direction. So these have high gain and narrow focus, so that sending and receiving stations must be carefully aligned. It's not line of sight per se, but it's close to it. Okay, so these are used for point-to-point, often to connect buildings. Omnidirectional antennas are the more common antenna that users, or common antenna on an access point that users would be connecting. It radiates the signal beam out all directions. Lower gain but wider coverage area. Okay, and also more potential sources of interference. Now you can have an omnidirectional antenna and still have it pointed in a particular direction. So sometimes organizations will stick their omnidirectional antennas in the corner of the building, but point it facing into the building. Okay, not facing out, not facing halfway, and that's to reduce the the connectivity area outside of the building. Okay, so pretty straightforward on the two antenna types if you really just think about it, and that's what they have on the exam. Wireless channels is another choice. Within the 2.4 and the 5 gigahertz frequency ranges, we have multiple channels. 802.11b and 2.4 gigahertz really only has 3 non-overlapping channels. Those are labeled in red here. 1, 6, and 11 are those channels. When you are configuring wireless networks, you might want to consider the choice of channel for best performance, especially in very populated areas where there are other wireless networks. Okay, auto sensing is the one that's automatically chosen, but in some cases it's better to actually manually configure different access points to use different channels. Having said that, if you go beyond and we're only using 802.11n AC or AX, this becomes less and less of an issue because of the broader frequency range in the 5 gigahertz frequency band. There's a lot more non-overlapping channels. As a part of the planning of a wireless network, sometimes you might do a site survey. Site surveys are used to scope out a building in order to determine exactly where the access points should be placed. That can be assisted, and generally is, by management software that could be provided by the access point. It could also be provided just with mobile devices. There are lots of free apps and things that you can get down that are wireless analyzers. This is more than just looking at the number of bars that you've got on your laptop or on your phone that's connected to an access point. No, this actually will help to define coverage areas, show the overlaps, those kinds of things, and it's necessary because with wireless connectivity and interference, it's sometimes difficult to predict. So if you are actually planning it out, doing a site survey wirelessly is a very good idea. In this next topic, we're going to look at remote access. This is another staple of most network environments that you'll deal with. The need to be able to connect from remote locations into the corporate network and to work as if I was at the corporate location. Okay, I believe I mentioned before, in the nature of today here in 2022 with the pandemic that we've all gone through, this is even become much greater. So organizations moved for months in some cases to a complete work from home solution, and then since that's been relaxed, still we see a lot of organizations that are utilizing remote access much more than before. So this has always been an important topic. It is a topic that's on the exam as well, and it's very important from a real life perspective. All right, so let's start with an introduction to remote networking. The general term is remote access. Just means we're providing remote connections to computers. We're utilizing public media. Historically or traditionally, this was phone lines. However, of course, since the advent of high-speed internet, really since the early 2000s, this has all been over high-speed connections via the internet. But within remote access, there are two kinds. We have remote node and we have remote control. And we need to understand the difference between those two different types. So remote node connects you to the remote network as if you were physically there. All right, like as if you physically pulled a cable and connected it to the corporate network. Remote control is actually the ability to remotely control a desktop. Okay, now the two can go hand in hand, but they are not synonymous. So remote node means clients are connecting to a remote network using a remote access server, sort of a generic term for VPN server. It provides the connection endpoint, again, traditionally dial-up, now VPN connections, and it provides authentication and authorization capabilities for those remote clients. Microsoft has routing and remote access. Unix and Linux have remote access capabilities, as do Apple. And then you have physical devices such as firewalls, VPN concentrators, VPN head-ins, and these are available from all different vendors. Cisco has FortiGate, Fortinet firewalls, Meraki firewalls, ASA. HP has their own firewalls. SonicWall is a particular type of firewall. Barracuda has VPN capabilities. All right, so it's not necessarily important that we know each one of those or even be familiar with them in particular, just to know that there are multiple options when it comes to remote connectivity. But the key here is when you remotely connect to that network, you simply obtain an IP address from that remote device, and that IP address works on the remote network. Remote control is a little bit different. Here we call it remote desktop control, because what some people mean when they mean remote access is the ability to log into my computer from a different location as if I was sitting in front of it. Okay, well that's remote control. With a VPN and standard remote access, you get an IP address, so you could access internal applications, web servers, you could access internal file shares and whatnot, but you're still utilizing whatever desktop you're sitting at. You're not actually remotely connected to a computer on that network, but that is what remote control can do. Windows XP introduced the program of Remote Desktop for Windows, and it's been included in every version since. Remote Desktop can be used on the local area network or through remote connections. However, Remote Desktop is going to require firewall and port forwarding configuration. So you basically have to tell the firewall, hey, when somebody connects on this port 3389, we need to forward that traffic back to a server or an individual client. There's a lot of third-party products that are available. LogMeIn and PC Anywhere were some of the original ones. TeamViewer is another that's been used in the last 10 to 15 years. It still is used. I don't know how often PC Anywhere is used anymore personally, but TeamViewer definitely. These would just involve an application running on a computer that you are then using the same application on a remote machine to connect into directly. So remote control protocols provide connectivity between the systems in a situation where the remote system actually does all the processing and it sends screenshots back to the client. So the remote client is simply sending mouse and keyboard strokes to that server or desktop, and then we're getting screenshots back. Okay, so RDP is the most common. It's not enabled by default, but it's available in the business versions of Windows Vista and later, and technically XP. Again, nobody's running XP anymore. Nobody's running Vista, we hope. But you still run into a few Windows 7, Windows 8, 10, 11. They all support it in the business versions. They do not support it in the home version, just so you know. It does provide data transfer, audio and video, and encryption, and it operates on port 3389. VNC was another desktop sharing system. That one's independent of any specific platform, and so it's available on a number of different operating systems. That one uses Remote Frame Buffer RFB protocol, which allows client-server determination of the best version to use prior to them being able to connect. It also offers different levels of password security and encryption. In this demonstration, we're going to look at how to configure remote control in both the Windows 10 and 11 operating system as well as on Windows servers. Okay, in Windows, the client machine, you're going to need to go to Settings, and then you're going to be in the system area, and we go down to Remote Desktop. Now this is in Windows 10 or 11, a little bit different. Just so you know, the Settings app, some people find it hard to locate stuff. I am one of them. Unless you get used to where it is, you can always just click Find a Setting and just type it in. Okay, so this is called Remote Desktop, and as soon as you do it, it's going to take you right to the Remote Desktop settings. Now, on a client machine, Remote Desktop is going to be off by default. And so you would have to go in and turn it on. And in order to turn it on, to be able to remotely connect to that specific machine, you are going to have to be running the business version, okay? The business or professional or enterprise versions. You cannot be running the home version. Home version can be used to connect to other things, but you cannot remote desktop into the home version, and that's consistent with both Windows 10 and Windows 11. So it's simply turn it on, and by default, all administrators are going to be able to connect to that machine, but you can add additional user accounts again, it says any members of the administrators group can connect. So even if somebody's not listed here, like a domain administrator, for instance, they're still going to be able to connect to it. Let's look at the remote desktop client. So the remote desktop connection app, we can go ahead and open that up and we'll talk about some of these settings. First off, the computer name that you want to connect to and or the IP address, the username that you want to use, although you can put that in after the fact. We can save connection settings for later use. Display has to do with colors and the screen size and whatnot, and that can be useful if you're on a slow connection. Local resources can be useful because it allows you by default to copy and paste, but you can also connect drives. All right, now you get an extra warning when you do that, but it'll allow you to then move data between the hard drives of the remote system and your own hard drive. So that can actually be very beneficial. Some of these others, just how to deal with keyboard combinations, remote audio settings, etc. The experience is all about different features. Again, detect automatically is fine, and most of us are going to be dealing with fairly high-speed connections. But back in the day, we might want to, we would turn this to black and white. We would turn off animations and things like that. On the advanced tab, it's an actual very important setting, and this is if your company is using the remote desktop gateway. Remote desktop gateway serves as a single entry point into the network for RDP. Now you can automatically detect it, but sometimes we have to manually configure the remote desktop gateway. When we have done that, it technically doesn't matter what we've put in out here. See, by default, whatever name or IP address I put in here, that's the name or IP that it's attempting to connect to. But when you have the remote desktop gateway configured, it's actually kind of proxying that request through the gateway. And so that can be very beneficial when you have a large number of people that are needing to remote in. Maybe you have several remote desktop servers, so the gateway acts as a session broker and distributes traffic between them. So just a couple of things to keep in mind there. When you try to make this connection, it will attempt to connect. You'll be asked for a username and password. If that username and password is correct, then you will automatically connect to that server. Let's see. Okay, you're going to get this is the certificate. Remote desktop is secured via SSL, and so now I'm able to connect. And there is the server that we were just on. Now I already had a remote connection to it, which is why it dinged at me because it just disconnected my other one probably. On a Windows server, you need to go and make sure that the remote desktop is on. Okay, remote desktop is not turned on by default on a Windows server. Now, the reason that it's on in both of my VMs cases is because they are in the Azure cloud. And so because they're in the Azure cloud, well, that means that that's the only way to connect to them is via a remote desktop connection. And it's the Azure firewall that is allowing us in, although I believe that we've got rules in here as well for RDP. So if you go down in the Windows firewall, you're going to have remote desktop, 3 different rules. Those are enabled as soon as you turn it on. So do you have to have firewall rules? Yes. If you have a perimeter firewall, then you also have to allow it through the perimeter firewall and then have the feature be enabled. But at that point, you can use remote desktop and use remote control either to log on to servers or to other clients. Authentication is the process of validating the identity of an individual prior to determine whether they're authorized for a connection or authorized to access a particular resource. Remote access authentication is always necessary in order for us to grant you connectivity to corporate resources. We clearly would not want anybody and everybody to be able to connect. Okay, so when we connect via remote access, the very first step is identifying who we are. But remote access authentication differs from LAN authentication methods in that there are additional steps. Sometimes we need additional multi-factor authentication. There are different protocols that are being used than we would have on the internal system, and in some cases there are just additional security mechanisms. The security of system resources uses a three-step process called AAA. That's authentication, authorization, and accounting. Authentication is just the process of identifying who you are before you're able to connect. And that's done through a combination of methods like username and password, certificates, codes, on tokens, things like that. Authorization is determining the level of access that you have based on those credentials. So authentication has to precede authorization. But just because you are who you say you are, that doesn't necessarily mean you can do whatever it is you're trying to do. You might connect to the VPN server and say, I'm Patrick Lohner, here's my password. The VPN server says, okay, I recognize you, that's valid, but then checks the policy and sees, well, because it's this time of day or because you're a member of this group, you're actually not allowed to connect. So you were authenticated, but not authorized. Accounting is the third stage, and that involves tracking user activities and actions. That can include the length of connection time, access types, data transferred, etc. Now, there are several remote access protocols that are available. Challenge handshake authentication protocols, one of the older ones, uses a three-way handshake process. It is used by the original remote access protocol, PPP. Passwords never actually transferred over the network. Basically, the client asks the client makes a request to connect, the server sends a challenge, and the client then authenticates itself using that challenge algorithm, and the server then responds. The password's never actually transferred over the network because the password is incorporated with the challenge string, and it uses one-way encryption. So it's not even able to decrypt it. You're not able to decrypt it, and it's not the actual password. It's the password plus the challenge string. So it's pretty secure. Microsoft has their own versions, V1, V2, which are more secure because they have stronger keys and they support mutual authentication. Extensible Authentication Protocol, EAP, is an extension to point-to-point protocol that includes multiple authentication methods. There's a lot of different methods that exist. The most common are EAP TLS, which would be used with a smart card, EAP MD5, which is used for username and password, and then protected EAP or PEAP, which actually protects the initial connection. We also have point-to-point over Ethernet, PPoE. That's a standard that's used to provide connection and authentication for DSL connections. It validates the MAC address of the connection or connecting computer. And then finally, you have password authentication protocol. PAP will likely never be the answer to a question because it only supports plain text. A protocol that's been common for 20 to 25 years, which we mentioned in the wireless section, is Radius, Remote Authentication Dial-In User Service. This provides a mechanism in which all AAA functions can be centralized. So the clients, in this case, in a VPN scenario, the client is the actual remote access server. And the remote access server then forwards the connection attempt using Radius to a central device. It improves security, it provides a scalable architecture, and it provides interoperability with other systems. We'll throw in something a little more modern now, which is multi-factor authentication. This is kind of the rage these days, and in requiring more than just a username and a password to connect, requiring you to be able to get a text message on a phone, or answer a phone call, or have an app that prompts you with a notification that you have to approve. Not in every case, but in many cases, in conjunction with VPNs, that works by using Radius. We turn the VPN endpoint, the remote access endpoint, into a Radius client of a Radius server. And the Radius server is then configured to allow you in only if you provide that additional level of authentication. All right, so we've mentioned a VPN. We need to understand what this is. Virtual Private Network is a point-to-point connection over a public network that emulates a private link. So data is encapsulated between two endpoints using a data transmission technique known as tunneling. The header provides the routing information, okay, so source IP, destination IP of the tunnel endpoints, but the data inside is protected using encryption. So if I were to capture the packets over the public network, they would be useless without the appropriate encryption keys. VPNs, again, it's nothing new, but they're used heavily these days to securely transmit traffic over the internet. A couple different types of VPN tunnels. The tunnel is the logical path across a network, so it looks like a point-to-point connection between two endpoints, when in reality it's not. It's just that only the two endpoints can decrypt the data, so nobody else sees it. Compulsory is established by the WAN carrier without involving the client. A compulsory VPN means that it's between two individual endpoints, and the client doesn't have to support the VPN type or the protocol in use. This is used for what are called site-to-site VPNs or partner VPNs. So it would be the first graphic between two VPN gateways. And what we're saying is that the PCs on both sides don't actually need to be configured for the VPN. They don't even have to have any knowledge that the VPN exists. The data is automatically transferred over that VPN tunnel through the internet when users on subnet A have information to share with subnet B. VPNs have become kind of the way of the modern wide area network. Whereas a voluntary VPN is created by the client. So the client is one endpoint and the VPN server is the other endpoint. Now this one is also called a remote access VPN or just client VPN. And it does require you to configure a connection or an application on the client. And you have to support the protocols, and it has to be configured in a very particular way. So compulsory or site-to-site VPNs are always on between two gateways. Voluntary or client access VPNs are switched on and off, and the client has to have the application or connection to do so. Next, we have the concept of encapsulation. Most common type is generic routing encapsulation, GRE. This is a tunneling protocol that was developed by Cisco for tunneling various protocols over a VPN. It's used by point-to-point tunneling protocols for remote access VPNs and site-to-site VPNs. GRE is also used by IPsec VPNs, and it is supported by a wide variety of network devices. So here are the VPN components to a solution. You have the VPN client and the VPN server running compatible protocols, compatible connections, etc. You have the virtual tunnel network over the internet as well. Okay, and that's just how we are communicating with one another. There are two different kinds of tunnels, which I don't have in the slide, but split tunnel versus full tunnel. Full tunnel means all traffic, all external traffic from the client is going to be routed through the VPN tunnel. What's more common these days is to use a split tunnel. And the split tunnel means that all internet traffic goes out through the normal connection and only traffic destined for the corporate network goes through the tunneled connection. If it doesn't seem obvious, it will, that, you know, the split tunnel idea is actually much better from a performance standpoint because it does route all traffic, even internet traffic, through that system. Authentication procedures are initiated by the VPN server against a domain database. Once you're authenticated and authorized to connect, then you get an IP configuration that's provided by the VPN server or DHCP. A lot of different encryption types. I wouldn't spend a lot of time on this. The Microsoft point-to-point encryption was used by PPTP and requires the use of either MS-CHAP or EAP. It provides strong and standard encryption, 128-bit to 56-bit. I say don't spend a lot of time because these are not officially listed in the objectives, or MPPE isn't, you know, but you probably just want to recognize the acronym. IPsec is because it's in the security section, and it's something that we need to know. It's used by layer 2 tunneling protocol, and there are also now IPsec only types of VPNs. Okay, so it can use either data encryption standard, triple DES, or the advanced encryption standard. Most commonly today, it would be the last one there. And these are typically used with a VPN. They can be used independently of VPN to provide network layer encryption for traffic on the LAN, but that's far less common than seeing them with a VPN. A VPN concentrator or a head end is Going to provide tremendous increase in performance abilities and security. These introduce advanced encryption and authentication methods like MFA, token-based authentication, and they provide the ability to handle a much greater number of client connections. They also provide high performance, high availability, and scalability. Here are the three main VPN protocols. Point-to-point tunneling protocol is kind of the oldest one. It's allowed by most firewalls, and it's supported pretty much across the board. It does not require certificate infrastructure. The data encryption happens after authentication and is using MPPE. L2TP uses IPsec for its encryption, so it's got higher levels of encryption. But this is blocked by network address translation in some cases, unless it's specifically allowed. However, it does provide encryption and mutual authentication before user authentication and requires a public key infrastructure, meaning certificates. Secure Sockets Tunneling Protocol, now just known as SSL VPNs, provides a simple firewall configuration. It's supported starting back in XP Service Pack 3. Can use AES encryption. It does require a server certificate. In this demonstration, we're going to look at creating and configuring VPN connections. Now, I can't do this in my cloud-based computers because as soon as I try to connect a VPN, it'll disconnect me from them, and then I have to reboot. So instead here, I'm going to use just my local Windows 10 client. All right, so we're going to actually, let's do this and make sure we're disconnected. There are paid for utilities that you can use to create VPNs. That's predominantly for for privacy things. So NordVPN is one that I use. It's already connected to that. Need to disconnect. You have other clients depending on where you're trying to connect to. So not every VPN is going to use the built-in Windows client. So for instance, I have the AnyConnect client that I can use, sometimes use for client systems. Sometimes we use AnyConnect for my own personal workplace. And then we've just got a pre-configured settings. Usually it's just a name that you're connecting to. And in our case, it's also in conjunction with Duo MFA, so we have to do two-factor authentication. The test is not going to ask you about vendor-specific stuff. Instead, it's going to ask you about just the Windows client. So we're going to right-click and open up Network and Internet Settings. This is now on the Windows 10 operating system. I know a lot of our demos here have been on Windows 11. It'll look very, very similar on Windows 11. So when settings opens up, we're going to just click on VPN. Okay, then it'll have different VPN connections. I'm just going to add a VPN connection. We're using the Windows built-in provider. I'm going to call it Meraki just because that's where I'm connecting. And then I need the server name. Now in this case, this is just a big, long name that's used for that. For that particular VPN server. Dynamic. And we'll hope that I typed that all in correctly. The VPN type. And so here's where you have your different types of VPNs. IKAV2 is an IPsec only, and then we have SSTP, our L2TP, and then the older PPTP. Okay, so in this case, this is going to be the L2TP with IPsec, and then specifying a pre-shared key. Username and password, and then we can go ahead and put that in there if we want. I'll go ahead and put mine. All right, and then we hit save. Okay, now in this case, and in some cases, you may have to go in with Meraki VPNs. Again, this is specific, so it's not going to be something you get on the test, but I do want to show that you can go to change adapter options, and you will see the VPN in here, listed as WAN mini port, and then I can go to the properties of it. Okay, I can modify the name if necessary. Go to options if I wanted to remember credentials. Security settings. it's the security settings where we do need to make sure we've got everything correctly configured. And this is also where we would put that pre-shared key if we needed to modify that. Okay, actually we need to change this to require. And I think that is good. Okay, then we would just click connect in Windows 10. It's going to pop up here. I can choose that, hit connect, and it should make an attempt to connect to that network. That'll either succeed or fail. And it looks like it might fail. Again, I may have typed in that name wrong. We'll have to check that. But regardless, those are the steps that you're going to take to be able to connect to a VPN, in this case a Meraki VPN. AnyConnect has its own client. Windows VPN server would use the Windows client as well. And like I said, really the key here is not necessarily being able to connect, but just knowing where to go and configure those settings. All right, so we'll go ahead and cancel that. That really is going to complete the demonstration. Again, the only way that you would know is it would pop up and say you're connected, and then if you did an IP config, you would see that you had an IP address from the corporate network. So this is remote node connecting through a VPN server to access a local corporate network. All right, in this final topic, we're going to be looking at cloud and virtualization concepts. Of course, virtualization has been around for many years now, probably about 20. And the cloud concepts are really just the next evolution of virtualization, where the cloud is essentially just somebody else's data center that you are using as opposed to your own data center. But we still use the same virtualization concepts plus additional cloud concepts. It's very important for network professionals these days to at least be able to speak intelligently about cloud offerings and technologies that are available. So let's start though with virtualization, since that was the beginning. Virtualization is a set of technologies that has greatly increased in recent years due to the fact that there are numerous advantages in comparison with standard server infrastructure. Virtualization works differently than physical systems. In a physical system, you have a single physical server running a single physical operating system. Okay, in a virtual system, you have a single physical host that runs multiple virtual machines. Now, for all intents and purposes, from a client perspective, the virtual machine acts just like a physical machine. It's just the management of these systems that is different, because these machines are running simultaneously on the same physical host, but they're operating completely independently of one another. They can operate, or they can run, I should say, different operating systems. They can be performing different roles, and they provide us with a lot of flexibility. These virtual machines can access the hardware resources on that host as a physical machine would. It's just controlled in that they're isolated. So what are some of those benefits? Well, we already mentioned one, it's transparent to users. Users don't know they're connecting to a virtual machine versus a physical server. They can run different OSs on the same host and provide a variety of roles. In many cases, certain roles, especially in Windows, cannot be combined with one another, and running them as separate virtual machines on the same physical host will achieve that. It also gives us more efficient utilization of hardware resources. Today's servers are very high powered, and for certain network infrastructure roles like domain controllers, DNS, DHCP, they really don't require that much hardware. And so you can utilize the hardware, the extensive hardware of a single host for multiple virtual machines. A fewer physical host means a conservation of energy. Virtualization will also simplify server deployment, because these machines can usually be created within a matter of minutes and have the operating system installed very, very quickly. We can even utilize templates to further simplify the server deployment. And it provides server consolidation that would just simply not be possible without virtualization. So the first component in virtualization is the virtual machine host, and otherwise known as a hypervisor. And there are two basic types of these, type 1, type 2. A Type 1 hypervisor provides equal access to the hardware for both the host and the guest operating systems. What this really just results in is better performance for the guest operating systems. Type 1 hypervisors include Hyper-V from Microsoft, VMware's ESXi server, and Citrix Xen server. Type 2, all access to the hardware goes through the host system. It's fine for testing, it's fine for non-production workloads. Anything beyond that, though, you definitely want to use a Type 1 hypervisor. So Type 2 would be like Microsoft's old Virtual PC and Virtual Server, a VMware Workstation still exists, Sun's VirtualBox, which is from Oracle Systems. Those are Type 2 hypervisors. Now, certain components are common to most virtualization scenarios, and they provide us with high-performance computing environments for the hosting of VMs. Things like storage area networks. Storage area networks are a collection of physical disk in a SAN cabinet. There are multiple vendors that provide these, but the individual host and the VMs that they host are going to be directly attached to a private SAN, okay? And then they are given virtual hard drives that can span one or more physical hard drives. In addition, we typically see high availability setup, so we have multiple cluster nodes that are running VMs. The VMs can automatically be moved from one host to another should a failure occur, or the virtual machines can be replicated to another host, just as a form of disaster recovery. They can even be replicated to additional sites, referred to as standby sites. The utilization of cloud computing model is going to add several characteristics to virtualization. Okay, so cloud computing inherently does use virtualization, but it is the evolution of virtualization. And so we have things like self-service. Self-service means that in a cloud environment, I can go into the Cloud Administrative Portal, or CLI, and I can deploy new virtual machines on demand. Okay, I can deploy them when I need them. I can decide what level of hardware that they need. I'm going to pay for whatever I utilize in the cloud data center, but I can utilize however much I want. I can pay $50 a month. I can pay hundreds of thousands a month, depending on the type of environment that I'm trying to set up. So self-service goes kind of right along with on-demand provisioning, getting what you need in the cloud provider when you need it. Okay, we also have a couple of other terms: enhanced scalability and elasticity. Scalability is the ability to scale your product either horizontally or vertically. Horizontal scalability is basically adding multiple systems that facilitate the same type of connectivity. So instead of one web server, I may deploy 2 or 3 more web servers for peak time. In most cloud providers, that can even be done automatically. Okay, so that when performance levels reach a certain range on one machine, we can automatically deploy a duplicate machine to help balance the load. Conversely, when those performance metrics fall below certain thresholds, we can scale back. Okay, again, that's horizontal scaling. Vertical scaling is scaling the capacity of an individual virtual machine, and we can do that too, although horizontal scaling is usually easier. Elasticity, the primary difference is scalability is really talking about growing bigger, okay, not growing smaller. So elasticity is that ability to grow bigger and then grow smaller on an as needed basis. And one term that's not here but we need to understand is called multi-tenancy or multi-tenant environment. So cloud providers are providing a workspace for individual organizations. Each organization is identified to the cloud provider as a tenant. However, you can have multiple tenants, so multiple organizations utilizing the same cloud provider, and they are isolated from one another. They're kept separate from one another, albeit that does have some security implications because of where your data is stored. It's no longer stored on premise, but it's stored in the cloud provider. In this demonstration, we're going to take a look at the virtualization platforms that are out there. Specifically here, I'm connected into an ESXi server. As this is the main administrative console, and while that's not something that you're going to be, certainly tested on, this is probably one of the major ones that is out there. So we have the particular host that we're connected to, and then we can see the range of virtual machines just by clicking on virtual machines. You'll see the whole list. When you get into a virtual machine, you can just select it. We can also right-click here and create and register a new VM. Okay, now that's going to be something we do after in the next demonstration. We can see the physical storage that this host is connected to, and I chose this one just because it's connected to a number of different storage arrays called data stores. Right, and we can see the virtual networking. So we've got a voice, we've got a VM network, and then we've got iSCSI networks, voice VLAN, etc. You have virtual switches that are associated with those. We have physical NICs. These would be on the actual host itself. Okay, and then you can choose which networks those are connected to, and even firewall rules. So ESXi is a level 1 hypervisor. You are going to, once it's installed, you would just connect to the website, and it has a root login name that you would use to log in. Now, I don't have actually access to a Hyper-V server, but we'll just go to images.google.com here. And we'll see if we can't get some there. This is a role that can be installed on Windows servers. Okay, it's going to look very similar. Let's see if we can get this to kind of pull up a little bit bigger. So Hyper-V is a role that can go on Windows servers. This is a look at that Hyper-V console, same kind of deal, where you've got the ability to create and manage virtual machines. You've got a virtual switch manager. You've got a virtual SAN manager to manage storage. Hyper-V is a little late to the game in comparison to ESXi. That's why a lot of organizations continue to use VMware. ESXi is definitely more expensive, but it's a bit more capable. So that's kind of all I wanted to really show you. Again, you can use virtual or VMware Workstation. You can get Suns from Oracle's VirtualBox. VirtualBox is actually free, whereas VMware Workstation is not free. That will at least give you the ability to kind of create VMs, get into the VMs, see how you can manage them as if they were individual servers, how they operate as individual servers, how to set up storage and things like that. So that's going to complete this demonstration. Just wanted to take a quick look at some of the virtualization platforms that are out there. All right, so we've taken a look at a couple virtual hosts. Now let's look at some virtualization components. Hey, first things first, you have the host system. Hyper-V, ESXi, probably the most common. VMware seems to be the most common across the industry. And then you have individual virtual machines. Individual virtual machines will have software installed on them, operating system and application software, and they'll function just like a normal computer or server. They'll have hardware as well, which is a virtual equivalent to physical hardware. So we see CPU, memory, network cards, hard drives, etc. And we can see some of that in this screenshot, which is from Hyper-V. Okay, so we can increase the number of CPUs. We can increase or decrease the amount of memory. Memory can also be configured as dynamic when dealing with virtualization, so it can expand and contract as needed. We can have one or more network cards. Network cards are going to be associated with a virtual switch, which then is associated with a virtual adapter. So you don't have two NICs associated with the same physical NIC. Most of the platforms won't let you do that. Really, there's no point in doing it. But if a host has multiple network cards, then we can set up multiple virtual NICs. Hard disk are VHD or VHDX files in terms of Hyper-V. They're VMDK files for VMware. Those hard drive files can be fixed or dynamic, meaning they can be fixed in size, so it's 200 gigs and that's how big it is. Or it can be dynamic, where I say it's 200 gigs, but it is the ability to grow beyond 200 gigs. In some extreme scenarios, we might use pass-through hard disk. A pass-through hard disk is a virtual hard disk that has a one-to-one relationship with a physical hard disk. Most of the time, that's not the case. Your virtual hard disk files could all be stored on the same disk or set of disks within a SAN or even direct attached storage. With pass-through, that's not going to be the case, and you're dedicating a physical hard drive. As I said, that's typically for high-end performance scenarios, applications like SQL Server, for instance, database servers that require high disk input-output. All right, in this demonstration, we're going to go ahead and create and configure a virtual machine here in ESXi. We'll right-click and say we want to create and register a VM. We can create a brand new VM, or ESXi supports the ability to deploy from templates. If you have an existing virtual machine that moves from one host to another, then you can register an existing virtual machine. Here we give it the name. We call that ISB119. We're going to choose the operating system that it's going to have, and then the version, although you can still pretty much put whatever you want on here. Choosing the right one will be important in terms of capabilities. We're going to choose a data store, and sometimes there will be a reason to choose one or another, but I mean, we're basically just looking for one that has an appropriate amount of storage. Okay, so I'm going to use, let's see, we use, there we go. And then we're going to customize the settings. So like I said, virtual machines are going to have a set of virtual hardware, so you can specify the number of CPUs, the amount of memory that you want to use, the hard disk size. This machine is just going to function as a domain controller, so we don't need a ton. The network adapter that we're connected to, okay, and in this case you want to make sure that you're choosing the correct one so that it can communicate with the other virtual machines. The CD drive is going to be important as well, because in order to install the operating system, we typically need to use an ISO. Okay, so I'm going to go to our special store here that we have for that, and we've got servers, and we're going to choose Windows Server. Just make sure that that's 2019. No, that's 2012. It's hard to see until you click on it. Okay, there's our 2019 server image. So we're just going to select that we want to utilize that at boot. And then we'll hit next. And we'll hit finish. And then we can go in and modify the settings of any of that if we need to. But the VM should now be in the list. Let's go down to ISB119. It's not going to be turned on, so I'm going to need to click to power it on. And then we're going to have to click in here quickly so that I can tell it to boot from DVD. And if I didn't get it quick enough, which I didn't, then we'll go to guest OS and we'll send a Control-Alt-Delete to get it to reboot. Okay, so now it is booting up to the DVD. Now there was not a physical DVD, but it's booting up to that ISO. And going to just go through a Windows installation. So at this point, this looks exactly like it would if I was just installing Windows on a machine. So I'm just going to kind of go through and get this started. We don't obviously need to watch it complete, but we'll go ahead and do that. And just choosing the operating system, choosing the drive that it's going to install on, like a normal Windows Server setup. So I was just using an example of one that I needed to actually create today anyway, and it's going to function as an additional domain controller. We're going to choose the standard desktop experience here. Accept our licensing terms. This is all just Windows. This doesn't really have anything to do with the virtual machine. And I'll let it go. Now, with both Hyper-V as well as VMware, you have something known as the VMware tools that is going to be important to install. And so once it gets up and running, we'll install those VMware tools. That makes it easier to connect, allows you to copy and paste, do other things. And just from a performance standpoint, that's a good idea. All right. So again, That's really all that it takes to create a virtual machine. Obviously, you have to have the host, you have to have the disk image to be able to install Windows. Then once the system is up and running, you can interact with it over the network as you would any other system. So that's going to complete the demonstration where we looked at installing and configuring virtual machines. Along with the virtual computers, other network devices are virtualized in many environments in order to support the virtual data center and cloud technologies. So we do have the virtual switch. The virtual switch performs networking functions for multiple virtual machines. It can exist on a single host or across multiple hosts. Virtual switches can be configured for internal-only communication, which would allow just the virtual machines to communicate on the same host typically, or external connectivity in that the virtual switch itself is tied to an actual physical NIC. We can experience virtual routers and virtual firewalls as well. Especially in the cloud, there are a lot of appliances that can be deployed in this way and would have the same interface, the administrative interfaces, as their physical counterparts would. And in order to support cloud environments in which multiple tenants are utilized, the concept of software-defined networking, or SDN, which we've already discussed, is typically used. That's used as a method of isolation between the tenants. All right, so what is cloud computing? This is a sort of an ambiguous thing. It's vague for a lot of people. We use the term it's out in the cloud, but we don't really necessarily know what that means. Well, the cloud model represents the ongoing evolution of the data center using virtualization technologies and providing numerous advantages over a server-based model. Now, that sounds sort of like an advertisement. The NIST describes this, and I think even though it's a mouthful, it is a good description. So a model for enabling ubiquitous, convenient, and on-demand network access to a shared pool of configurable computing resources. Let's stop there, okay? You have convenient and on-demand access to a shared pool of resources. In other words, a data center, okay? That is the compute power, CPU, memory, the storage, the physical networking that you require access to. The cloud really is all about where the resources are, because in typical virtualization, the resources are on a host that's in your on-premise network. And so you stand up VMs based on the physical capabilities of that host, right? The number of VMs and the number of CPUs and memory you can allocate is all based on the underlying hardware. Well, in cloud technologies, we're doing the exact same thing. It's just I don't own the host. So because I don't own the host, I have less access to the host, but the cloud model allows me to have on-demand, pay-as-you-go scenarios. So I can get whatever I'm willing to pay for, essentially. And I can stand it up and utilize that. I can turn it off, stop utilizing that. You can rapidly provision and release with minimal management effort or service provider interaction. If I've got an agreement, a pay-as-you-go agreement, the cloud provider has my credit card, and they're sending me monthly invoices, I can do whatever I want so long as I continue to pay for it. Okay, so really the deal with cloud computing is where is the actual where are, I should say, the actual host? Where is the infrastructure on which we're building our virtual machines? Do I own it or does somebody else own it? So the problems with server-based infrastructure is that it requires physical hardware for every system. You have interoperability issues that require some servers to be, isolated so they can have certain applications and roles. That results in underused servers, and it results in all your data being stored locally. With cloud computing, we have a virtualized data center that is hosted and maintained by a cloud service provider like AWS, Google, Azure for the Microsoft Cloud. That results in a reduction in operational cost because it makes it very easy to deploy systems that I need. That deployment and provisioning is done self-service. It does not involve the cloud service provider, at least in the vast majority of cases, so long as you have an active agreement. Increased energy consciousness and improved resiliency and agility. One of the reasons I tell people a lot of companies go to the cloud is because they can achieve high availability and disaster recovery recovery setups that they would never be able to achieve with on-premise environments. They simply don't have the physical infrastructure to do this. But when I tap into something like the Microsoft Azure cloud, they've got data centers all across the world. So if you want to replicate one of your virtual machines to the other side of the country or the other side of the world, go for it. We have the capability of doing that. Whereas in an on-premise environment, I typically would not. All right, there's several deployment models that are mentioned here in the objectives, and we need to understand the difference. We've got private, we've got public, hybrid, and then there's one more called community cloud. The private cloud model is the one that's very confusing to people, because you're probably thinking, well, wait a minute, didn't you just say that cloud meant that the data center was somewhere else versus on-premise? And that is true the vast majority of the time. But there is such a thing as a private cloud. A private cloud is actually on-premises. So that means I host the data center, but I'm utilizing applications to provide cloud-like capabilities, self-service provisioning, on-demand deployment, elasticity and scalability, those kinds of things, okay? But I own the data center. Now, only very large companies will have their own private cloud. Just because you have a virtualization host and several VMs, that doesn't mean you have a private cloud. The real question is, can somebody go through some sort of administrative portal and request that a VM be deployed and have that VM deployed automatically and billed to them? If the answer is yes, you have a private cloud. If the answer is no, you just have an on-prem data center. Private clouds will use, and I'm really only familiar with the Microsoft one, it's System Center suite of products. And there are several components to that: Service Manager, System Center Orchestrator, System Center Config Manager, Data Protection Manager. There's about 6 or 7 different products within that suite, and it allows you to create your own private cloud. So private clouds allow for increased customization because we own the hardware. So we own the physical infrastructure, storage, network, and host. But in so doing, that also is going to increase administrative requirements. We have to have people that know how to manage those, set them up, and configure them. In a public cloud model, which is the more common, the provider hosts the fabric. That is storage, network, and compute. So the provider is hosting all of that. And my amount of customization level is going to depend on what's called the cloud services model, which we'll go through here shortly. Okay. There are no instances in a public cloud where I have access to the actual physical host, to the actual physical storage or physical networking devices. That's all abstracted from me. Okay, I may be able to create virtual machines and install operating systems on them and have full functionality like I would on-prem, or I may be just restricted within a particular application. That's where it's going to depend on the services model. And there's various administrative requirements as well based on the services model. Okay, if it's application only, we just need somebody who knows how to manage that application. If it's infrastructure as a service and you're setting up VMs, well, then we have to have somebody who's going to go in and be able to do all of that. And a hybrid is probably pretty straightforward. A hybrid is some mixture of the two. Some resources are on-prem, some resources are in the cloud, and there's typically a connection of sorts between those systems. Now, I will say the word hybrid gets used in several different places. So like in Exchange email systems, an Exchange hybrid setup is where the Exchange application has some mailboxes on-prem and some mailboxes in Office 365. That's an Exchange hybrid. That's not really how the term's being used here. Oh, it kind of is, but it's particular to an application. We've got the same kind of thing with local Active Directory domain services versus Azure AD domain services. And those can be set up in a hybrid just for that particular application. Okay, so again, it's just sort of it's kind of vague, and you have to dig in when anybody uses the term hybrid. But in general, it just means some resources on-prem, some resources in the cloud. A community cloud is a public cloud, but it's only available to businesses of particular types. The best examples of this, at least in my brain, are the the Azure Government Clouds. They call them GCC, and it stands for Government Community Cloud. In order to subscribe to resources in that cloud, you actually have to be a part of the government or a DoD contract, and you have to, kind of go through the approval processes of getting access to that. There's a GCC, and then there's a GCC High Security Cloud. So those are community clouds, and there are others out there. Again, a particular type of organization. You have to fit into that mold before you can be a part of that cloud. Okay, let's talk about cloud services models. There are other cloud services models, but these are the most common. Infrastructure as a service, platform as a service, and then software as a service. Now, if you notice here, what it's saying, this is what you manage. So if you manage your own stuff, then you manage it everything. You manage the underlying infrastructure, server, storage, and networking, the virtualization host, the operating systems in the VMs, the data, the application, you manage all of that. In infrastructure as a service, we're going to start there. The provider is managing all of that underlying fabric, including the virtualization host. I have the ability to deploy virtual machines within that cloud provider, but I would be responsible for creating the virtual machine, installing and updating the operating system, configuring any networking with other systems, and configuring data and applications. Okay, so infrastructure as a service is going to give you the most control within the cloud provider's network. Platform as a service is the next step up. Here, the operating systems, middleware, and runtime is also managed by the cloud service provider. Platform as a service is like, I'll give you an example. There's a SQL as a service offering in Azure where you can stand this up. Well, normally to stand up a SQL server, you'd actually have to install an operating system, update it, install prereqs, install SQL, etc. Right? With SQL as a service, you can stand up the SQL platform and be able to interface with it directly without having to manage the underlying servers. And there are a boatload of these. Different types of SQL, other types of databases, websites, .NET applications, it just kind of, the list goes on and on and on. But the key is you don't have to manage the underlying operating system. In software as a service, literally everything is controlled by the vendor. Okay, and what you see is what you get. Now, that doesn't mean you don't have any management capabilities, but it's all within an application. G Suite for Google would be an example of this. Office 365 is an example of software as a service in the Microsoft model. There's a third one that's not on this list. That's desktop as a service. This is a relatively new one that's allowing us to set up virtual desktops in the cloud and a virtual desktop infrastructure. And so it's providing access to a desktop, user profiles, and essentially just a remote workplace. In this demonstration, we're going to look at just working with cloud services. Now, I've got access to Azure Cloud. I don't really have access to AWS or Google. It's going to be very similar. This is in Azure, you've got both platform as a service as well as infrastructure as a service. In Office 365, you have software as a service. So those are the two that we're looking at. This is the Azure portal, and then this is the Microsoft 365 Admin Center or portal. In the Azure portal, we can create both infrastructure as a service as well as platform as a service. It starts, and the details here are not necessarily important, just want to show you some examples. We're going to start by a resource group. A resource group in the Azure cloud is a way for me to collect resources that are managed together. So I've got my own resource group in here. It's got the lab machine that I've been using. It's got the virtual networks. The lab machines have public IP addresses associated with them. There's the server, the disk, the network interface. You can see all of those. And I'll just show you how easy it is to create a virtual machine in an infrastructure as a service here. Okay, so we're just I'm gonna choose the correct subscription, and let's see, let's go with the resource group. I don't know why that, actually, let me go back here. I'm gonna do this a different way. So I'm gonna go to my resource group and then hit create within it. And then notice, so I can create Windows servers, I can create different Linux variants. A lot of these are going to be potentially platform as a service. Let's just create a Windows server. All right, so again, I'll have to choose that, the subscription, I'll have to choose the resource group, the server name. -2, not underscore. The region that you're in, the region in Azure's case does have to do with the availability stuff that you can set up. So there are high availability options. I don't need those. High security options, don't really need those as well. And then I can choose the size. Okay, so this is going to build one with 4 virtual CPUs and 16 gigs of memory, and it's giving me the, this is how much it's going to cost a month. Maybe I don't need that much, and so I can go and I can say, well, you know what, 2 CPUs and 8 gigs of RAM is fine for me, and that'll cut down the cost. So there you see kind of what we've been discussing, and you get what you pay for. What you want, you can have whatever you want. You just have to actually be willing to pay for it. But we can expand and scale as much as we need to. Let me retype that. There we go. Inbound port rules. So there's going to be a firewall. By default, it's going to allow port 3389. We're going to use an existing Windows license. And I'm going to be able to choose disk. I can add additional hard drives if I want. Okay, I can choose the network that I'm going to associate this with. So it's going to be just going to put it on the default subnet. Basic network security. These are the ports that we're going to allow in. And we hit review and create. And then from there, it's just going to go through and validate all of our settings, and we can hit create. But it's amazing to me. I mean, this will take maybe, I don't know, 30 seconds, maybe a minute while our deployment is in progress here before it's actually deployed. And so it's very high speed, and you can deploy entire networks, if you will, virtual machines, virtual networks, subnets within those virtual networks, applications installed on the virtual machines. Now, again, this is infrastructure as a service. If I'm deploying a virtual machine, and you can see that deployment has already succeeded, then I am responsible for installing software in this virtual machine, patching this virtual machine, protecting it, all of those things. Okay, but I can say I want to connect via RDP. It'll give me the public IP address, and I can hit download. A couple other things, I can go over to networking and hit the interface and say, I want to go to this public IP address, and I want to actually make it static. Because otherwise, every time I reboot the system, it's going to change IP addresses, which makes it difficult. Now, you have to pay a little bit more for static, but fine. Or the alternative is leave it dynamic, but give it a DNS name. And so the DNS name stays the same, even though the IP address is going to be different. Okay, let's go back to the network interface. Another thing that we would have is going to be the, oh, I guess that's not correct. Let's go here and then networking, and then we're going to go to, this is where I needed to be. This shows the effective rules. So right now it is allowing port 3389 from anywhere. We probably want to scale that down and put in some source networks to not leave this kind of open to the public. But that is something that you can do. So we have firewalls there that can be configured as well. Also, within our resource groups, we could create other services. Oh, I don't want to create a resource group, sorry. I want to go to the resource group that I had set up, and I want to create something in here. Okay, so I'm just going to put in firewall. And we've got multiple firewalls. We've got the Azure firewall that can be created. We've got a NGF, next generation firewall from Palo Alto. We've got a web application firewall there. And then sometimes you just need to search by the name. Okay, so FortiGate, for instance. There is a FortiGate solution, next generation firewall. And when you click on this, It will walk you through how to set it up, single VM versus high availability. This technically would be a type of platform as a service. Okay, it is a VM, but you don't really have access to the VM. In this case, you just have access to the web page that configures the Fortinet FortiGate firewall. So that gives you a couple of examples of infrastructure as a service versus platform as a service. And then over here, we've got software as a service. Okay, this is the Microsoft 365, formerly known as Office 365. I believe I have an account in here. Yeah. So we've got an account, and I've got a particular license that's associated with that account. That license is going to give me access to Exchange Online, SharePoint Online, Teams, and other things. And so we can create accounts, we can assign licenses, and give people mailboxes. Okay, now within, since that's a mailbox, I've got management tools for the mailbox portion of this. So I can go to the Exchange Online Admin Center, click on mailboxes, and I do have some control in here. It's just the control that I have is limited to the software itself. Okay, so for instance, in a normal Exchange Admin Center, I'd see something about servers over here. Well, I'm not going to see that. I don't have to create databases or anything like that, but I can actually go and configure email related settings because this account has a license within this particular tenant. So those are the differences. And again, it's a quick look just because I don't want you to get bogged down in the details. But what's important for you to understand is the difference between infrastructure as a service, platform as a service, and software as a service as it relates to the level of control that you would have as an admin. So we've seen all three examples now in the Microsoft Cloud, and that's going to complete this demonstration. In this chapter, we looked at various network implementations. We started with network services, DNS and DHCP predominantly, and looking at the functionality that those provide and the importance of that functionality on our networks. We talked about various wireless implementations and showed how to configure access points to different security protocols and wireless technologies. We talked about the importance of remote access, both remote node, which is your typical remote access through a VPN, or remote control using remote desktop or other third-party applications. And then finally, cloud and virtualization, the capabilities that are there for us in the modern enterprise.